Imagine for a moment that everything we know about the universe and how it works could suddenly change. For decades, we have believed, based on Albert Einstein's theories, that nothing with mass can travel faster than the speed of light. This idea has been like a rule book for the cosmos, shaping our understanding of how stars, galaxies, and even light itself behave. But what if there is a way around that speed limit? Scientists today are exploring new ideas that might allow us to bend the very fabric of space. If these ideas work, we could one day travel to distant stars much faster than we ever thought possible, turning distant points of light into reachable destinations and giving humanity a chance to explore the universe like never before.
Looks at going to the moon one day and to Mars, and to get to Mars, they're going nuclear.
It may sound like pure science fiction, the kind of thing you'd see in a movie or read in a novel, but the concept of a warp drive has gone from a whimsical fantasy to a topic that serious scientists are beginning to consider.
They call the action, which is to do with the mass of the particle and the time and the distance, so you basically calculate these little quantities.
If space could be contracted in front of a spaceship and expanded behind it, the ship wouldn't technically be traveling faster than light in the usual sense. Instead, it would be changing the shape of space itself to shorten the journey. While this still exists mostly in theory, recent research and mathematical models have hinted that maybe, just maybe, it's not completely impossible. The reason this is such a big deal is that it challenges the cosmic speed limit set by Einstein's special theory of relativity.
Cool thing is Einstein's field equations, you can actually play with them. The equations are right there. You can add things to the, right or left-hand side.
According to Einstein, as an object with mass moves faster, it needs more and more energy to keep speeding up. And at the speed of light, it would need infinite energy, something we simply cannot supply. Over the past century, this idea has seemed unbreakable, forming the bedrock of modern physics. It has guided how we view everything from the motions of galaxies to the orbits of electrons. It set the rules of the cosmic game. But now, with people questioning whether space itself could be manipulated, we find ourselves standing at the edge of a grand new possibility. What would it mean if we could actually achieve faster-than-light travel? Right now, space travel is slow. Even the fastest spacecraft we have would take tens of thousands of years to reach the nearest star system. Voyager 1, launched in 1977, took 35 years just to leave our solar system. The distances between stars are mind-bogglingly large. Without a new way to travel, interstellar exploration will remain out of reach for many generations to come. But with a warp drive or some other method of faster-than-light travel, everything changes. Journeys that now seem impossible could be completed in a human lifetime. Instead of staring at the stars and dreaming, we could go there, see them up close, and maybe even set foot on planets orbiting those distant suns. Of course, this is all still in the realm of theory. The challenges are enormous. One big issue is energy. The amount of energy needed to create a noticeable warp in space, based on our current understanding, would be far beyond anything we can produce. Another problem is that the theories often require something called negative mass or negative energy, exotic forms of matter and energy that we have never observed in nature. Without them, the equations don't quite work out. Still, the fact that scientists are considering these things seriously means that our understanding of physics might not be as final as once thought. Sometimes new discoveries can open doors we never knew existed. The possibility of faster-than-light travel also has huge consequences for how we think about the universe. If we can find a loophole in the laws of physics that lets us break the light barrier, what else might we discover? Perhaps we could explore star systems that we previously only knew as distant points of light. Imagine visiting a planet like Proxima b, which orbits the star Proxima Centauri, the closest star to our solar system after the Sun. Proxima b is just over 4 light-years away, which might as well be infinity with current technology. At the speed of our fastest spacecraft, it would take thousands of years to get there. But if we had a warp drive, we could, in theory, make the journey in a fraction of that time. Proxima b is a fascinating target. Early research suggests that it is a rocky planet only slightly more massive than Earth, sitting in its star's Goldilocks zone, where conditions could allow liquid water on the surface. This naturally leads to the question of whether life could exist there. Finding life outside our solar system would be the biggest discovery in human history, changing our understanding of biology, evolution, and our place in the cosmos. But Proxima b also faces challenges. Its star, a red dwarf, bathes the planet in harmful radiation and likely bombards it with frequent solar flares. This could strip away its atmosphere and make the environment hostile to life. Still, the planet remains an object of intense study because it challenges our definitions of habitability. Today, scientists are using advanced tools like the James Webb Space Telescope and precise instruments called spectrographs to learn more about distant planets. They measure the starlight filtering through a planet's atmosphere to determine what gases it contains and whether conditions might be suitable for life. The more we learn, the clearer it becomes that there are many factors to consider when deciding if a planet can support life. Distance from the star is important, but so are the star's activity level, the planet's magnetic field, and the composition of its atmosphere. Studying planets like Proxima b helps us broaden our understanding of what habitable can mean. To get even better data, people are thinking up bold new missions like the Starshot initiative. Starshot aims to send tiny spacecraft propelled by powerful lasers toward the Alpha Centauri system. These tiny probes could travel at a fraction of the speed of light, cutting the travel time to decades instead of millennia. While still slow compared to what a warp drive might achieve, it's a significant step forward. If successful, Starshot probes could send back images and measurements of Proxima b's environment, giving us a much closer look at a planet beyond our solar system. This kind of exploration also raises important ethical questions. If we ever do manage to travel at or near the speed of light and reach other worlds, what do we do when we get there? Should we try to terraform a planet that already has life, even if that life is very simple? How can we ensure that we do not harm other ecosystems? As we expand into the galaxy, we have to consider our responsibilities as not just explorers, but also guardians of life, wherever we may find it. Our actions have consequences, and colonizing another world might mean changing it forever. These moral dilemmas remind us that space exploration isn't just about technology and physics. It's also about values and understanding our place in a grand, interconnected tapestry of life and matter. Beyond the question of traveling fast, scientists are also looking at the biggest mysteries of the universe. Consider black holes, those strange cosmic objects with gravity so intense that nothing, not even light, can escape once it crosses the event horizon. For a long time, black holes were just curiosities and equations, but now we know they are real. We've even seen images of them with powerful telescopes. The more we learn about black holes, the stranger they become. Some scientists even wonder if black holes could be factories for new universes. It sounds wild, but the idea goes like this. Inside every black hole, there might be a region where the laws of physics break down, giving rise to conditions that resemble our own universe's Big Bang. If that's the case, maybe our universe itself was born inside a black hole from another universe. This theory, while not proven, challenges our basic understanding of time, space, and reality. If black holes do create new universes, then what does that say about our place in the cosmic hierarchy? We might be living inside a black hole right now, with our entire universe existing as a kind of bubble in a larger reality. Each black hole we see in our universe might then be like a seed for another universe beyond our own cosmic horizon. If any part of this idea is correct, it would mean that the reality we know is just one of countless universes, each with its own properties, some more suited for life than others. Over time, universes that produce more life-friendly conditions could become more common, leading to a kind of natural selection on a cosmic scale. But we must remember that these ideas, while fascinating, are still largely speculative. We don't have the tools or the knowledge to peek inside a black hole to see what's happening there. For now, these remain intriguing possibilities that inspire our imaginations. As our technology advances, we keep pushing our understanding to new limits. Projects like the Event Horizon Telescope have already shown us a black hole's shadow, and gravitational wave detectors have begun to detect the ripples of black hole mergers across the universe. The more we learn, the more questions we have. Could black holes explain the mysterious dark energy that is driving the expansion of the universe? If our universe is inside a black hole, maybe the incredible expansion we see is related to the intense gravitational environment at play. Again, these are very tentative ideas, but they show just how far we're willing to stretch our thinking in pursuit of understanding. While all this is going on in the realm of the very large, we're also exploring new concepts by looking at binary star systems. Many stars don't live alone. They come in pairs, orbiting a common center. This dance between two stars can have huge effects on their evolution. Sometimes material flows from one star to another, changing how they shine, how long they live, and even how they might end their lives in spectacular supernova explosions. Supernovae are not just impressive fireworks. When they explode, they forge heavy elements like gold and uranium. These elements get scattered across space, seeding new star systems and planets, and ultimately contributing to the formation of planets like ours. By studying binary star systems, scientists can learn how matter cycles through the galaxy and how stars shape their environments. Consider T Corona Borealis, a binary star system that may be on the verge of a nova event. One star, a white dwarf, pulls matter off its companion star, a red giant. Eventually, this buildup can lead to an explosion bright enough to see from Earth. Such events give astronomers a front-row seat to cosmic processes and allow them to test their theories about how stars behave. Studying these dramatic events helps us understand how elements are distributed throughout the galaxy and how the life cycles of stars help create conditions necessary for planets and possibly life to form. In fact, the elements forged in these fiery deaths of stars eventually form rocky planets like Earth. The iron in your blood, the calcium in your bones, the gold in your jewelry, they were all made in the hearts of stars and scattered when those stars died. By observing binary star systems and supernovae, we learn more about where we come from. We are quite literally made of stardust, and each piece of evidence we gather brings a new appreciation for the interconnectedness of everything in the cosmos. The universe recycles matter on an enormous scale, and understanding that process can deepen our sense of connection to all that exists. As we dream about traveling faster than light and visiting planets like Proxima b, as we ponder the origins of our universe and the nature of black holes, and as we study binary star systems to understand the life cycles of stars, we find ourselves continually pushing the boundaries of what we know. Every time we learn something new, we open more questions. Could we one day send people or sophisticated robots to these distant worlds? Could we unravel the mysteries of dark energy and dark matter, which together make up most of the universe's energy content, yet remain almost entirely unknown to us? Will we find life out there, or are we alone in this vast cosmic ocean? These questions drive scientists, engineers, and thinkers to keep searching, experimenting, and inventing. Just a few decades ago, the idea of imaging a black hole would have seemed like an impossible feat. Today, we have done it. A century ago, the notion of measuring gravitational waves from merging black holes billions of light years away would have seemed outlandish. Now it's almost routine. Who's to say what we might achieve in another century, or even in a few decades? The possibility of faster-than-light travel might seem like the stuff of dreams, but dreams have a way of inspiring us to do great things. Even if warp drives turn out to be too difficult or impossible, the research that tries to make sense of them could lead to other discoveries. Perhaps we won't fold space like a piece of paper, but in the process of trying, we might learn more about quantum mechanics, gravity, or the structure of the cosmos. That knowledge could lead to inventions and technologies we can't even imagine today. The same applies to our search for life on other worlds. Even if Proxima b turns out to be barren, the methods we use to study it will help us analyze other planets. Eventually, we might find one that truly is like Earth, with oceans, continents, and atmosphere that's just right, and maybe even life forms that share the universe with us. Our careful approach to these discoveries will shape how we interact with newfound life, teaching us humility and responsibility as we move out into the stars. Thinking about living inside a black hole or being part of a vast network of universes might sound far-fetched, but big ideas have always been part of the scientific adventure. Sometimes the wildest notions turn out to contain a grain of truth that leads to profound breakthroughs. Even when they don't, they push our minds to think beyond the everyday and consider the deeper nature of reality. As we refine our theories, build better telescopes and detectors, and maybe one day harness new forms of energy, we'll continue to expand our sphere of understanding. Binary star systems, supernovae, and the formation of heavy elements show us that the universe is a place of constant change and complexity. Nothing stays the same forever. Stars are born, shine, and die, spreading the ingredients for new generations of stars and planets. Over billions of years, this cosmic cycle has produced the conditions that allowed life to arise at least once, here on Earth. Understanding these cosmic processes isn't just an academic exercise. It helps us appreciate just how extraordinary our existence is and how special it might be. In the end, all of these topics, faster than light travel, Proxima b, and the search for habitable planets, black holes as potential creators of universes, and the life cycles of stars, are about one thing: understanding our universe and our place in it. We live in a time when technology and curiosity can guide us to answers that were once thought impossible to find. We are explorers by nature, and as long as we keep asking questions, we'll keep moving forward. No one can say for certain what the future holds. Maybe we'll crack the secret of bending space and travel to distant stars in just a few years. Maybe we'll uncover solid evidence of life on an exoplanet. Maybe we'll discover that black holes link universes in a grand cosmic family tree. Or maybe we'll find that reality is even stranger than we can imagine. Whatever happens, the journey of discovery is worth the effort. The universe is vast and mysterious, but every step we take in understanding it brings us closer to feeling at home in the cosmos. As we learn more, our perspective grows. We become not just observers, but participants in a grand story that spans eons. From the tiny particles that challenge our understanding of light and gravity, to the enormous galaxies swirling through space, everything is connected in ways we are only just beginning to understand. All we can do is keep exploring, keep questioning, and keep pushing the limits of what we know. In the end, whether or not we find a way to travel faster than light or confirm the wild theories about black holes and multiple universes, our efforts to understand these things help us grow. They remind us that knowledge is never complete and that there is always more to learn. We are explorers on a never-ending journey of discovery. The universe is full of surprises, from the strange possibilities of warp drives to the deep mysteries hidden in black holes and binary stars. Each new idea challenges what we thought we knew and invites us to look deeper. By continuing to study, explore, and imagine, we may one day turn dreams of interstellar voyages into reality, broaden our understanding of life in the cosmos, and embrace our role as travelers in a vast and magnificent universe.
We are one step closer to answering the age-old question, are we alone in the universe?
The James Webb Space Telescope has found an Earth-sized planet.
Just 3 minutes ago, the James Webb Telescope made an amazing discovery of a green planet that might support life. This new world, glowing brightly in space and full of promise, may even be a future home for us. Its striking color and friendly conditions spark hope and excitement. Let's find out what makes this planet so truly special and how it could change our view of life beyond Earth.
This week, NASA unveiled pictures from a new space telescope capturing the deepest images of the universe.
The James Webb Space Telescope, JWST Overview. The James Webb Space Telescope, or JWST, is one of the most advanced space observatories ever built, launched in December 2021. JWST is the successor to the Hubble Space Telescope, designed to look deeper into the universe than ever before. Its mission is to explore the first galaxies that formed after the Big Bang, study the formation of stars and planets, and search for signs of life on distant exoplanets. JWST is equipped with a 6.5-meter primary mirror, which is more than 2.5 times larger than Hubble's mirror. This large size allows it to collect more light, making it possible to see fainter and more distant objects. The telescope is also designed to operate primarily in the infrared spectrum. Infrared astronomy is crucial because it allows JWST to see through cosmic dust clouds that often hide the objects astronomers want to study. One of the key features of JWST is its highly sensitive instruments. These include the near-infrared camera, NIR-CAM, the near-infrared spectrograph, NIR-SPEC, and the mid-infrared instrument, MIRI. These tools enable JWST to capture detailed images and spectra of celestial objects. By analyzing these spectra, scientists can determine the composition, temperature, and motion of stars, galaxies, and planets. JWST's mission goals are ambitious. It aims to observe the first stars and galaxies that formed in the early universe, providing insights into the origins of cosmic structures. Additionally, JWST is tasked with studying the atmospheres of exoplanets, particularly those in the habitable zones of their stars. The habitable zone is the region around a star where conditions might be right for liquid water to exist, a key ingredient for life as we know it. Unlike its predecessor, Hubble, which primarily observes invisible and ultraviolet light, JWST's infrared capabilities allow it to see objects that are too old, distant, or faint for Hubble to detect. This makes JWST a powerful tool for uncovering new stars and planets that were previously hidden from view. JWST operates in a location called the Second Language Point, or L2, which is about 1.5 million kilometers from Earth. This position allows the telescope to stay in line with the Earth as it orbits the Sun, providing a stable environment for observations. The L2 location also helps JWST maintain its extremely low temperatures, which are essential for its infrared instruments to function correctly. Since its launch, JWST has been delivering stunning images and valuable data to scientists around the world. Its discoveries have already reshaped our understanding of the cosmos, revealing intricate details of galaxies, nebula, and star-forming regions. The telescope's ability to analyze the atmospheres of exoplanets has opened new avenues in the search for extraterrestrial life. Now that you know the telescope's secrets, let's see how it found this incredible green world. Discovery of the habitable green planets. Verdantia is an Earth-sized exoplanet located approximately 500 light-years away from us in the constellation of Orion. What makes Verdantia particularly fascinating is its distinct green hue, which indicates the presence of abundant plant life. This green color is a result of chlorophyll in the planet's vegetation, suggesting that Verdantia could have a thriving ecosystem similar to Earth's. The planet orbits its star, Star Orionis, which is a stable yellow dwarf star slightly cooler than our Sun. Verdantia resides comfortably within the habitable zone of Star Orionis, where temperatures allow for liquid water to exist on its surface. Liquid water is essential for life as we know it, making Verdantia a prime candidate in the search for extraterrestrial life. One of the most compelling pieces of evidence supporting Verdantia's habitability is the analysis of its atmosphere. JWST's mid-infrared instruments detected signs of water vapor and oxygen in the planet's atmosphere. The presence of oxygen, along with water vapor, is a strong indicator of potential biological activity. On Earth, oxygen is primarily produced by photosynthetic organisms, which further supports the idea of abundant plant life on Verdantia. JWST observed the planet's surface features, revealing vast oceans and extensive land masses covered in greenery. These observations were made possible through JWST's advanced imaging capabilities, which can penetrate the thick atmosphere of Verdantia to provide detailed views of its surface. The planet's climate appears to be mild and stable, with temperatures ranging between 15 to 25 degrees Celsius, ideal conditions for human habitation. Verdantia's orbit around Star Orionis is also noteworthy. The planet completes an orbit every 365 days, mirroring Earth's orbital period. This similarity not only stabilizes Verdantia's climate, but also suggests a consistent day and night cycle, which is beneficial for maintaining life cycles similar to those on Earth. The discovery of Verdantia was a collaborative effort involving multiple observatories and space agencies, while JWST played a crucial role in identifying the planet and analyzing its atmosphere. Ground-based telescopes provided additional confirmation of Verdantia's existence and characteristics. This collaboration highlights the importance of international cooperation in advancing our understanding of the universe. Scientists are particularly excited about Verdantia because it represents a significant step forward in the search for Earth-like planets. While many exoplanets have been discovered in recent years, Verdantia stands out due to its promising signs of habitability and the potential presence of life. The planet's green vegetation, water-rich environments, and breathable atmosphere make it one of the most Earth-like exoplanets discovered to date. Further studies are underway to gather more data about Verdantia. Scientists aim to determine the planet's exact composition, surface conditions, and potential for sustaining human life. These studies will involve detailed spectroscopic analysis and continuous monitoring of Verdantia's atmosphere and weather patterns. Curious how scientists spotted this world? Let's break down the discovery method. How JWST discovered the planet. JWST primarily used the transit method to detect Verdantia. This method involves observing the slight dimming of a star's light when a planet passes in front of it. As Verdantia transits across star Orionis, it blocks a small fraction of the star's light, creating a temporary dip in brightness. By carefully measuring these dips, scientists can determine the presence of a planet, its size, and its orbital period. Once Verdantia was identified through the transit method, JWST conducted detailed observations to study the planet's atmosphere. The telescope's near-infrared spectrograph, NIR spec, was instrumental in this process. By analyzing the light that filters through Verdantia's atmosphere during transit, NIR spec can detect specific wavelengths that correspond to different molecules. In Verdantia's case, NIR spec detected signatures of water vapor and oxygen. These molecules leave distinct patterns in the light spectrum, allowing scientists to identify their presence and estimate their concentrations. The detection of these molecules is a strong indicator of potential biological activity, as they are commonly associated with life processes on Earth. Additionally, JWST utilized its mid-infrared instrument, MIRI, to capture high-resolution images of Verdantia's surface. Infrared imaging is particularly effective for studying exoplanets because it can penetrate the planet's atmosphere and reveal surface features. MIRI's observations showed extensive green vegetation and vast oceans, providing visual evidence of Verdantia's Earth-like environment. The high-resolution capabilities of JWST were crucial in distinguishing Verdantia from other exoplanets. The telescope's large primary mirror and sensitive instruments allow it to collect more light and produce clearer images than previous space telescopes. This enhanced sensitivity enables JWST to study fainter and more distant objects, making it possible to detect subtle signs of habitability on exoplanets like Verdantia. Data analysis played a significant role in confirming Verdantia's characteristics. Scientists used sophisticated software to process the raw data collected by JWST. This involved filtering out background noise, correcting for instrumental errors, and calibrating the measurements to ensure accuracy. The processed data was then analyzed to extract meaningful information about Verdantia's atmosphere, surface, and overall environment. To further validate the discovery, ground-based telescopes and other space observatories were used to observe Verdantia. These additional observations helped confirm the planet's existence and provided supplementary data to support JWST's findings. The collaboration between different observatories ensures that the discovery is robust and reliable. JWST's ability to perform spectroscopy was also essential in studying Verdantia's atmosphere. Spectroscopy involves splitting light into its component colors, or spectrum, to identify the presence of specific elements and molecules. By examining the absorption lines in Verdantia's spectrum, scientists could determine the composition of its atmosphere with high precision. Moreover, JWST's advanced imaging technology allowed for the creation of detailed maps of Verdantia's surface. These maps reveal the distribution of land and water, as well as signs of vegetation and other surface features. Such detailed imaging provides valuable insights into the planet's climate, weather patterns, and potential for supporting life. With the process revealed, find out why this discovery is so groundbreaking. Significance of the discovery. First and foremost, Verdantia represents a major step forward in our search for habitable worlds beyond our solar system. Finding an Earth-sized planet within the habitable zone of its star with signs of water and oxygen is a rare and exciting discovery. It provides concrete evidence that habitable planets are not just theoretical, but exist in the vast expanse of our galaxy. From a scientific perspective, Verdantia offers a unique opportunity to study the conditions necessary for life. By analyzing its atmosphere and surface features, scientists can gain insight into how life may arise and thrive on other planets. This knowledge can help us understand the potential for life elsewhere in the universe and the factors that make a planet habitable. The discovery also has profound implications for the theory of planetary formation and evolution. Verdantia's existence challenges some existing models and prompts scientists to refine their theories about how planets form and develop over time. Studying Verdantia can reveal new information about the processes that lead to the creation of habitable environments, enhancing our overall understanding of planetary science. For humanity, Verdantia represents hope for the future. As our population grows and resources on Earth become strained, the possibility of colonizing another planet becomes increasingly appealing. Verdantia's Earth-like conditions make it a potential candidate for human habitation, offering a new frontier for exploration and settlement. However, the journey to colonize Verdantia is not without its challenges. The distance of 500 light-years means that traveling to the planets with current technology is not feasible. Nevertheless, the discovery ignites interest in developing faster propulsion systems and advanced space travel technologies that could make interstellar travel possible in the future. Moreover, Verdantia serves as a reminder of the importance of preserving our planet. As we search for new homes among the stars, it's crucial to take care of Earth, ensuring that it remains a viable habitat for generations to come. The discovery of Verdantia highlights the delicate balance required to sustain life and the responsibility we have to protect our environment. In addition to scientific and practical implications, Verdantia has a significant cultural impact. The discovery captivates the public imagination, inspiring people around the world to take an interest in space exploration and astronomy. It fosters a sense of wonder and curiosity, encouraging the next generation of scientists, engineers, and explorers to pursue careers in these fields. Educational institutions can leverage the excitement surrounding Verdantia to promote STEM, science, technology, engineering, and mathematics education. By incorporating the discovery into curricula, teachers can engage students with real-world examples of scientific achievement and the ongoing quest to understand the universe. Now that we've seen why Verdantia is so promising, let's compare it with other exoplanets to see what sets it apart. Comparison with other exoplanet discoveries. One of the well-known exoplanets is WASP-96b, discovered by the Wide-Angle Search for Planets WASP project. WASP-96b is a gas giant located about 1,150 light-years away in the constellation Phoenix. While it is not Earth-sized, WASP-96b has been studied for its atmospheric composition, revealing the presence of water vapor and clouds. However, its proximity to its star makes it extremely hot and inhospitable for human life. Another interesting exoplanet is LHS-475b, found in the constellation Octans, just 40.7 light-years from Earth. LHS-47b is slightly smaller than Earth and orbits a red dwarf star. It has a rocky surface and a carbon dioxide-rich atmosphere. Although it shares some similarities with Verdantia, LHS-475b is much hotter and has a shorter orbital period, making it less suitable for colonization. HD 21749c is another exoplanet discovered by the Transiting Exoplanet Survey satellite, TESS, located about 1,120 light-years away. HD 21749c is an Earth-sized planet orbiting a slightly smaller star than our Sun. It resides within the habitable zone, but its atmosphere is primarily composed of carbon dioxide, raising questions about its potential to support life. Kepler-186f, discovered by the Kepler Space Telescope, is one of the first Earth-sized planets found in the habitable zone of its star, located approximately 580 light-years away. In the constellation Cygnus, Kepler-186f is similar in size to Earth and orbits a red dwarf star. While it shows promise, its exact atmospheric composition remains uncertain, making it difficult to confirm its habitability. K218b, another exoplanet observed by JWST, orbits a red dwarf star about 124 light-years away. It is known for its hydrogen-rich atmosphere and the presence of water vapor. However, like many other exoplanets, K21AB faces challenges such as extreme temperatures and potential atmospheric loss, which complicate its habitability prospects. Compared to these exoplanets, Verdantia shines due to its combination of favorable factors: an Earth-like size, a green hue indicating plant life, a stable and breathable atmosphere, and a location within the habitable zone of a sun-like star. These attributes make Verdantia a standout candidate for further study and potential human habitation. Every big find has its hurdles. Let's explore the challenges next. Challenges and controversies. One of the main challenges is the distance of Verdantia from Earth. Located 500 light-years away, sending a mission to explore the planet is currently beyond our technological capabilities. This immense distance means that even with advancements in propulsion, it would take thousands of years to reach Verdantia using conventional space travel methods. Overcoming this hurdle requires significant breakthroughs in space travel technology, which is still in the early stages of development. Another challenge is the confirmation of Verdantia's habitability. While the presence of water vapor and oxygen in the atmosphere is promising, it does not definitively prove the existence of life. Further observations and more detailed studies are needed to understand the planet's environment fully. Scientists must carefully analyze the data to rule out alternative explanations for the detected atmospheric components, such as volcanic activity or abiotic processes. There is also skepticism within the scientific community regarding some of the initial findings. Some scientists argue that the detection methods might have limitations, leading to potential inaccuracies in the atmospheric composition analysis. This skepticism is a natural part of the scientific process, as peer review and further research are necessary to validate the discovery. Technical limitations of JWST also pose challenges. While JWST is a powerful tool, it has its constraints, such as resolution limits and the potential for instrumental errors. Ensuring that the data collected is accurate and free from biases requires ongoing calibration and testing of the telescope's instruments. Despite these obstacles, the future of space exploration shines bright. See what's coming. Future of space exploration. One of the most exciting prospects is the development of next-generation telescopes and probes. Building on the success of JWST, scientists are working on more powerful observatories that can provide even more detailed information about distant exoplanets. These telescopes will enhance our ability to study the atmospheres, surface, and climates of potentially habitable worlds, bringing us closer to confirming the presence of life beyond Earth. Technological innovations in propulsion and space travel are also crucial for future exploration. Current spacecraft are limited by their speed and range, but advancements in propulsion technologies such as ion drives and nuclear propulsion could significantly reduce travel times to distant exoplanets like Verdantia. These innovations will make interstellar missions more feasible, opening up new frontiers for human exploration. International collaboration will play a vital role in advancing space exploration efforts. The complexity and cost of missions to study exoplanets require cooperation between countries and space agencies. Collaborative projects can pool resources, expertise, and technology, making ambitious missions more achievable and efficient. Artificial intelligence and machine learning are set to revolutionize how we analyze and interpret vast amounts of astronomical data. These technologies can help identify patterns, detect anomalies, and make predictions about exoplanet characteristics more quickly and accurately than traditional methods. By automating data analysis, scientists can focus on deeper insights and more complex questions about the universe. Private sector involvement in space exploration is also growing. Companies like SpaceX and Blue Origin are pushing the boundaries of what's possible, developing reusable rockets and other technologies that could make space travel more affordable and accessible. This involvement complements the efforts of government space agencies, accelerating progress and innovation in the field. Looking further into the future, the concept of interstellar travel becomes a tangible goal. While still in the world of science fiction today, advancements in propulsion and energy technologies could one day enable humanity to reach other star systems. projects like Breakthrough Starshot aim to develop miniature spacecraft capable of traveling to nearby stars at a fraction of the speed of light, potentially allowing us to reach planets like Verdantia within a human lifetime. The discovery of Verdantia by the James Webb Space Telescope marks a monumental step in our quest to find a new home among the stars. As we continue to explore the cosmos, who knows what other wonders await us? If you enjoyed this video, make sure to like, subscribe, and hit the notification bell so you won't miss any of our future explorations.
And now, the James Webb Space Telescope is identifying objects in the dark ages that, by best measurements we have, are large, fully developed galaxies.
At last, the James Webb Space Telescope image we've been waiting for is here. Researchers worldwide are stunned by what it revealed about our universe's early days. The striking snapshot challenges old assumptions and invites us to reconsider our cosmic history. Could we be on the brink of rewriting the story of the Big Bang? Join us as we explore the discoveries and the surprising questions that have surfaced today.
That's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
The James Webb Challenge. The James Webb Space Telescope, often called JWST, was designed to see farther into the cosmos than ever before. By collecting infrared light, it can peer through dust clouds and reveal structures hidden from older instruments. Scientists consider it a key tool for studying the first stars and galaxies, which formed when the universe was still young. This telescope's large mirror and cutting-edge detectors allow it to detect faint signals that date back billions of years. From its position beyond Earth's orbit, JWST offers a clear view of deep space without the atmosphere's interference. Its mission involves tracing how stars and galaxies took shape after the Big Bang. Astronomers hope it can answer important questions about dark matter, dark energy, and the role of early black holes. Already, it has returned images that capture details we never imagined seeing in such ancient corners of the universe. The telescope's infrared vision was chosen because the light from very distant objects is stretched or redshifted by the universe's expansion. By studying those stretched wavelengths, JWST uncovers hidden clues about the chemistry of early galaxies and stars. Past telescopes gave us partial glimpses, but JWST's unprecedented sensitivity now helps us map out the earliest chapters of cosmic history. NASA officials note that each new batch of data reveals unexpected features. Some galaxies appear more mature than standard theory predicts, hinting that star formation may have raced ahead in ways we still cannot fully explain. Researchers marvel at how fast we must adjust old models. The telescope's ability to see faint glows from the first few 100 million years challenges previous assumptions and leaves experts debating how these systems assembled so rapidly. Results from JWST also shed light on the formation of heavier elements, which have a direct link to star birth and evolution. By analyzing light signatures, astronomers identify whether certain galaxies held large amounts of carbon, oxygen, or metals early on. These findings reshape our notions about how quickly the first supernova might have enriched their surroundings. Enthusiasm for JWST's discoveries runs high. It is not just revealing data points, but offering a broader vision of the cosmic timeline. Students, hobbyists, and professional scientists alike share in the excitement of these crisp images. The scale of detail we can see urges us to question what else has yet to be uncovered in this uncharted world. This might be our best chance to witness the early universe as it truly was, packed with secrets. Are we ready to accept that ancient galaxies emerged faster now? Contradictions to the Big Bang. Since the mid-20th century, the Big Bang concept has guided our efforts to explain how the universe began. This model describes a hot, dense starting point that expanded and cooled, eventually allowing atoms, stars, and galaxies to form. The discovery of the cosmic microwave background bolstered this view, as did evidence for cosmic inflation. Yet the new data from the James Webb Space Telescope has thrown fresh doubts on certain timelines and growth rates. These observations hint at galaxies that appear too evolved for their place in cosmic history. Traditional theory says it should take many hundreds of millions of years for such large systems to assemble, but JWST has revealed candidates that seem to contradict that, suggesting rapid star building or alternative processes. Could the rate of early growth be more extreme than we once assumed, or are we dealing with errors in interpretation? One possibility is that we lack a full picture of how matter and energy behave in extreme environments. If the early universe held regions of higher density, star clusters might have merged faster, forming robust galaxies in less time. Another idea is that dark matter played an even bigger role by clumping more aggressively, accelerating the process of galaxy formation. Still, not everyone is ready to abandon core Big Bang principles. Some propose measurement mix-ups. Redshifts can be tricky, and gravitational lensing could skew perceived sizes. Alternatively, certain faint signals might come from active black holes instead of full galaxies. Researchers also note that dust can affect brightness estimates, making objects look older or more massive than they truly are. Ongoing work aims to refine these details, checking if extraordinary claims match more precise data. Debates about the Hubble constant and cosmic expansion add further intrigue. If the universe expands at a rate different from what we expected, that difference could shift timelines. In response, some theorists propose adjusting early expansion parameters. Others suggest we might need fresh physics to bridge all the gaps. While no single piece of data has overturned the Big Bang framework, cracks in the standard narrative keep growing. For now, experts urge patience. Future spectroscopy and deeper surveys should confirm which galaxies genuinely defy accepted gases. Whatever the outcome, it seems clear that the story of our cosmic origins remains more complicated than a simple outline in textbooks. We may be standing at the edge of a revolution in how we interpret the earliest epoch of star and galaxy formation. Is it possible that these puzzling observations mark the start of a sweeping rewrite of our cosmic timeline, surprising early galaxies? Astronomers are calling some of these newly spotted systems universe breakers because they seem to appear far earlier than expected. Instead of the small, dim clumps predicted by standard models, JWST has revealed the massive galactic structures bursting with stars. These objects challenge the idea that galaxies form slowly from smaller pieces. Instead, they suggest that enormous systems can emerge within just a few 100 million years after the Big Bang. Scientists looking at high redshift data found star masses rivaling or even exceeding those in our Milky Way. Yet these galaxies were born when the universe was only a tiny fraction of its current age. Traditional theories say such large collections of stars should take much longer to develop, involving multiple mergers over eons. So how did they get so big so quickly? Could there be a mechanism that jumpstarts star formation in certain regions? Some experts propose that the densities in those early epochs were much higher than assumed, allowing gas to collapse into stars at a rapid pace. Others wonder if supermassive black holes lurking at the centers played a role in fueling star creation. Another angle is that these galaxies might not be as mature as they appear, with bright regions of star formation skewing estimates. JWST's astonishing sensitivity, though, leaves little doubt that something unusual is going on. What truly shocks researchers is the variety of these surprising galaxies. Some displayed clear spiral or disk features, forms usually linked to lengthy evolutionary paths. Others look more chaotic but still house impressive star populations. The data also indicate a wide range of chemical elements, implying that supernova may have enriched these galaxies much sooner than many thought possible. As studies continue, astronomers piece together each puzzle fragment, comparing results from different filters and wavelengths. They want to see if these monsters are common or just a few oddballs. If common, we may have to rethink the timeline of star birth and heavy element production. If rare, they might represent special conditions that let matter clump together at record speed. Regardless, these findings have caused experts to question whether current models can capture all the details of cosmic dawn. There was talk of new simulations that tried to replicate these quick-built galaxies, exploring extreme density fields or exotic physics. For the public, it means the early universe was far more dynamic, energetic, and unpredictable than we imagined. Are we prepared for the possibility that even our updated theories might fail to explain how these galactic giants formed so fast? Alternative explanations. When faced with surprising data, scientists naturally look for ways to reconcile fresh observations with established ideas. One suggestion is that supermassive black holes might cloak themselves in vast clouds of dust, mimicking the signature of a larger galaxy. If that happens, what seems like a star-packed disk could be an extreme black hole outflow. Refined measurements could reveal if hidden black holes cause us to overestimate star counts. Other points to errors in reading redshift values. Certain dusty objects can appear very red even if they are not as old or distant. Also, gravitational lensing by foreground clusters may enlarge images, leading us to assume that objects are bigger or older than reality. In that case, the cosmic timeline might remain intact, and these universe breakers would be illusions produced by lens effects. Dark energy or exotic forms of dark matter could also shift normal growth rates. Some researchers think that early dark energy might have briefly accelerated expansion, condensing material in ways that spark early star formation. Another notion is that primal magnetic fields or turbulence in the young universe triggered pockets of intense collapse. Each path tries to explain how robust systems emerged so quickly. Many experts stress that not all anomalies result in rewriting entire theories. Sometimes, new data simply refine existing frameworks, observing more galaxies, sampling different parts of the sky, and applying advanced tools can sharpen our understanding. Over time, seemingly impossible objects might fit into a revised model. The challenge is deciding which modifications are correct. Yet the tension remains. Some propose that the early era was not as uniform as we believed. Maybe certain patches of the universe contained extreme conditions where matter clumped at record speed. Others suspect we have overlooked key physics related to star formation at very high densities. Until researchers gather more spectra and cross-check distances, the debate will continue. A deeper question underlies it all. How flexible is our standard cosmic model? Experts remind us that scientific models are never final. They adapt whenever strong evidence demands it. Whether these galaxies are outliers or signs of a deeper shift, they invite us to push the boundaries of theory. Does our hunt for clarity hint at a grander mechanism lurking behind the scenes, waiting to be uncovered by the next wave of observations? The role of black holes. Black holes are our natural suspects whenever we see extremely high mass or odd motion. In the early universe, supermassive black holes might have shaped galaxy growth by pulling in gas, creating intense radiation, and possibly driving star formation bursts. Some astronomers wonder if these dark giants formed sooner than we expected, boosting the development of galaxies that JWST now spots as mature in cosmic infancy. This puzzle deepens because black holes themselves can be hard to detect directly at great distances, especially if they hide behind thick dust. High-energy jets or bright accretion disks could appear as strong infrared sources, which JWST would pick up. If the light we see belongs more to black hole activity than starlight, that could inflate mass estimates for early galaxies. Researchers hope to test this by examining emission lines that might prove the presence of active galactic nuclei. Roger Penrose has proposed that black holes might even come from a prior era, though that idea remains controversial. Proponents believe traces of older cycles might persist, but linking that to early galaxies is speculative. Still, theories about rapid black hole seeding keep growing, pushed by surprising detections of active cores in smaller galaxies. If black holes can form and grow faster than once assumed, their gravitational effects might accelerate star formation. Others take a simpler view. They say the universe can produce big black holes if conditions are right, such as dense gas pockets that collapse straight into massive seeds. If that happened frequently, we might see black hole-driven galaxies at redshifts that defy older timelines. Yet confirming such processes require more observations and advanced modeling. Astronomers aim to cross-match radio or X-ray data with JWST images to see if these galaxies host hidden cores. If yes, black holes might be behind the illusions of giant stellar populations. If not, then we'd likely face a genuine revision to how fast stars can appear. Either outcome would reshape how we see the interplay between darkness and light in the cosmos. Are massive black holes the real engines of early cosmic growth, or have we only scratched the surface of an even greater mystery? Cyclic cosmology proposals. Some scientists argue that the biggest issues with early universe data might be answered by considering models beyond the single Big Bang. Roger Penrose's conformal cyclic cosmology suggests that our universe is just one phase in an endless sequence. Each cycle ends in a far future state where black holes evaporate, leaving behind conditions that set the stage for the next bang. This bold idea implies that certain clues from previous eras could remain hidden in the cosmic microwave background or the distribution of black holes. Penrose points to patterns called Hawking points, which might be remnants of black hole decay from an early cycle. Such claims spark heated discussion. Skeptics note that conventional Big Bang theory already explains most data without needing repeated cosmic resets. Still, the discovery of galaxies that appear too mature could inspire a second look at cyclic theories. If the universe has had multiple expansions, perhaps star formation is triggered differently each time. Supporters say it could make sense of how large structures manage to form so swiftly. Maybe they have roots in leftover energy or subtle geometry from a prior epoch. Critics replied that we lack direct proof of a preceding cycle and caution against jumping to conclusions. For them, new data about ancient galaxies means refining known physics, not discarding the Big Bang. Whether cyclical or not, these models stress the ongoing quest to understand the universe's ultimate origin. If we accept a repeating timeline, the notion of a true beginning might vanish, replaced by a cosmic loop. Others prefer a simpler story, where inflation and the Big Bang remain fundamental. Still, Penrose's theory draws attention because it tries to handle problems like entropy and black hole mysteries in a single framework. The James Webb Space Telescope, by probing the earliest observable era, could either support or contradict cyclical cosmology. If evidence for prior cycles surfaces like strange anomalies in the microwave background, then the door opens to radical shifts in how we view time itself. Until we gather more data, the topic remains a source of lively debate. Is the universe we see just the newest chapter of an eternal book, or do these surprising galaxies merely reveal a cosmic plot twist we have yet to decode? The future of our universe. The striking results from JWST have nudged scientists to reconsider details once thought settled. If large, massive galaxies existed sooner than expected, textbooks may require updates. From star formation rates to the timeline of cosmic evolution, gradual adjustments are normal in science, but these leaps in data quality suggest that deeper changes might be on the horizon. Observatories around the globe plan to combine forces with JWST to survey more distant regions and confirm these early galaxy findings. Next-generation telescopes on Earth, like the 30-meter telescope, will offer high-resolution spectroscopy. Meanwhile, space-based missions may focus on the faint ultraviolet or X-ray emissions that could clarify whether black holes or star populations drive these new surprises. The goal is a cohesive map of galaxy growth throughout cosmic history. A broader implication is the potential shift in how we envision the universe's ultimate fate. If matter assembled rapidly at the start, might other unknown processes shape the far future? Some argue that new physics could change predictions for dark energy's effects on cosmic expansion. Others think we will adapt existing theories, leaving the broad framework of the Big Bang intact but tweaking key details. Collaborations between theorists and observers will be crucial. The mismatch between data and models might lead to fresh concepts, including exotic matter or revised inflation scenarios. Even quantum gravity theories might come into play if standard approaches cannot account for these fast-forming galaxies. It's not the first time astronomy has prompted such large shifts. Think back to how discovering galaxies beyond the Milky Way remade our entire cosmic perspective. Excitement is balanced by caution. Researchers emphasize that these results must be validated throughout rigorous checks. If they hold, a wave of innovative solutions could emerge. The public, too, has become fascinated by the possibility that we stand on the verge of breakthroughs. Education, from classrooms to documentaries, will likely adapt once a clearer story emerges. The long-awaited James Webb Telescope image has sparked debates and excitement, revealing galaxies and structures that outpace what our usual models predict. These findings may reshape how we view the Big Bang, star formation, or even the concept of cosmic cycles. As more data arrives, we might be on the edge of a new era in cosmology. What do you think about these results? Share your thoughts below, and remember to like, subscribe, and stay curious. The universe always has more stories to tell us.
Oh my gosh, okay. Well, we knew this would happen, but it's amazing that we can fool the universe into saying, we know you gave off ultraviolet when you're born, and we're gonna look for you in the infrared. You're not gonna get by us. So, we make the James Webb Space Telescope.
Have you ever looked up at the night sky and wondered what lies beyond our tiny corner of the universe? From twinkling stars to distant galaxies, space has always fueled our curiosity. NASA has helped turn those dreams into discoveries with groundbreaking telescopes like Hubble, which gave us breathtaking views of planets, nebulae, and more. But now, there's a new game changer, the James Webb Space Telescope.
The James Webb Space Telescope is good for stuff nearby, just as it's good for stuff long ago. All right, so now let's tune the telescope in to galaxies being born.
Over the years, NASA has launched several legendary telescopes: Hubble, Spitzer, Chandra, and more. Each of these observatories played a role in giving us a clearer view of the cosmos. Hubble, in particular, revolutionized our understanding of space with images so sharp and vivid that they ended up on classroom posters, magazine covers, and even coffee mugs. It has scanned distant galaxies, peered into star-forming regions, and given us glimpses of planets orbiting stars many light years away. But technology never stands still. Engineers, scientists, and astrophysicists have always dreamed of building something even better than Hubble, something that could see deeper into the universe's past. That dream is the James Webb Space Telescope. Although it was extremely expensive and took longer than expected to design and launch, the end result has been nothing short of remarkable. JWST can observe in infrared wavelengths, which allows it to see objects and regions of space that are hidden by dust when using visible light alone. Infrared vision is a game changer because it can peer through cosmic clouds to reveal forming stars and the earliest galaxies. Some of these objects and events date back to a time when the universe was still in its infancy. Before we continue, test your wits with Aura's "Are You Smarter Than a Scammer?" quiz, link in the description.
We don't understand how galaxies are born. Let's make a telescope to help us.
What makes JWST particularly special is its power. It's been said that it's up to 100 times more powerful than Hubble. That number doesn't just mean slightly crisper images. It suggests that JWST can capture faint signals from some of the earliest moments after the Big Bang. Light takes time to travel, so when we see galaxies that are billions of light years away, we're effectively looking back billions of years in history. If a star is 5 billion light years away, the light we see now left that star 5 billion years ago, long before Earth was the planet we know today. This sort of cosmic time travel helps astronomers study how stars and galaxies formed in the very early universe. With each new image JWST provides, scientists have the opportunity to refine their theories about the age of the universe, the process of star birth, and the arrangement of cosmic structures like galaxy clusters. These images give us a sharper look at places such as the Carina Nebula, a vast region of gas and dust where stars are born, or Stephan's Quintet, a tightly packed group of galaxies that appear to be dancing around each other due to gravitational interactions. Images of SMA CS 0723, a massive cluster of galaxies, also hold fascination. Because of how gravitational lensing works, objects behind the cluster are magnified, letting JWST spot galaxies so faint and distant that we might never have detected them otherwise. But what does any of this have to do with the topic of traveling to these distant stars and exploring them up close? After all, if the closest star to us beyond our sun is over 4 light years away, how could we ever hope to get there in a reasonable amount of time? Think about our attempts to reach Mars. Even that journey within our own solar system can take around 5 months. Sending astronauts to the red planet is already a massive challenge, and Mars is practically in our cosmic backyard. Now compare that distance to the one between us and the nearest exoplanet, which is Proxima b. It's orbiting Proxima Centauri, a star over 4 light years from Earth. That's roughly 25 trillion miles away. If we tried to travel there using our current spaceship technology, it would take thousands of years. Clearly, we need a new approach if we ever hope to explore worlds beyond our star system. That's where the idea of a warp bubble comes in. You might already know about it from science fiction like Star Trek, where spaceships zip around the galaxy at speeds greater than the speed of light. Physicists have long believed that nothing can move faster than the speed of light in a vacuum, which sits at about 186,000 miles per second. That speed limit is one of the cornerstones of Einstein's theories, and for good reason. If you could move faster than light, bizarre situations would arise, including time travel to the past and other paradoxes. But the warp bubble concept gets around this rule by reimagining what it means to move through space. Instead of moving an object faster than light through space, The idea is to move space itself around the object. Think of a surfer on a wave. The surfer isn't moving across the ocean at high speed under their own power. Rather, they're riding a wave that carries them forward. A warp bubble tries to do something similar by compressing space in front of the craft and expanding it behind the craft. So the bubble can travel immense distances faster than light would normally allow, without breaking relativity in the usual sense. One of the biggest reasons this is important has to do with the weird effects that come with traveling close to light speed. Time dilation is a phenomenon in which someone moving near the speed of light experiences time more slowly compared to someone who stays behind. If you boarded a spaceship that could travel faster than light in a conventional sense, you'd risk coming back home only to find that years or even centuries had passed, depending on how fast you were going. A warp bubble, at least in theory, keeps the space inside the bubble untouched by these extreme relativistic effects. Inside the bubble, time moves normally for anyone on board, and time also flows normally for people outside. The ship simply rides a wave of distorted space from point A to point B. It sounds like science fiction, but it has a serious basis in mathematical physics. The earliest modern blueprint for this concept came from physicist Miguel Alcubierre, who in 1994 proposed what is now known as the Alcubierre drive. Building on Einstein's field equations, Alcubierre showed that if you could arrange spacetime in just the right configuration, you could achieve what amounts to faster-than-light travel without locally breaking the speed of light. The catch was that this required exotic matter with negative energy density. Negative energy is not something we encounter in everyday life. In fact, it's so strange that its very existence is still debated in the physics community. The need for negative energy was a huge obstacle because scientists had no idea how to produce or harness it in the large quantities necessary for an interstellar journey. This hurdle, combined with the enormous energy requirements in early models, led many to dismiss the Alcubierre drive as a neat idea but not workable in practice. Even if negative energy existed, the calculations initially suggested you'd need something like the mass energy of an entire star or a planet to power the bubble. That's not exactly the sort of thing you can pick up at your local hardware store. Yet as time has passed, researchers have tinkered with the equations, looking for more realistic versions of warp drive. One of these researchers is Dr. Harold Sonny White, who became known for his work at NASA's EagleWorks laboratory. He tried modifying the Alcubierre metric so that it demanded less exotic matter. The new version proposed smaller amounts of negative energy or exotic matter, bringing the dream of a warp drive one step closer to reality. Still, the question remained, even if you tweak the numbers, can you ever truly get your hands on negative energy? Not long ago, Dr. White and his team stumbled upon something surprising while studying the Casimir effect. The Casimir effect is related to the behavior of virtual particles in a vacuum. In quantum theory, space is never truly empty. It buzzes with fleeting virtual particles. If you place two very close metal plates together, the energies in the gap can be slightly different from the energies outside, leading to measurable forces. White and his colleagues built special structures known as Casimir cavities and analyzed the distribution of energy inside them. They found a pattern that appeared to suggest the presence of negative energy density. This was only at the microscopic nanoscale level, but it still raised eyebrows. Their result made them think, maybe we can create tiny warp bubbles in a lab. While this does not mean we can suddenly build a starship tomorrow, it does spark excitement. If negative energy can be created or harnessed in small amounts, who's to say we couldn't scale it up one day? That's where the James Webb Space Telescope might come into the picture in a rather indirect but still significant way. JWST is designed to detect very faint signals and see phenomena we've never observed before. If there are processes in space where negative energy or exotic matter might form naturally, perhaps near black holes, neutron stars, or other extreme environments, JWST's instruments might give us clues about how these processes work. By studying these places, scientists can refine their models of spacetime, gravity, and quantum physics. Such refined theories could help us figure out how to generate or manage exotic energy here on Earth. Admittedly, JWST is not a warp bubble detector in the sense of scanning the cosmos for faster-than-light travelers. Its primary goals are more grounded in astrophysics, studying early galaxies, star formation, the chemistry of exoplanet atmospheres, and more. But astronomy often yields unexpected discoveries. Hubble wasn't designed to find exoplanets, yet it helped pioneer the field of exoplanet studies simply by being able to detect dips in starlight or measure atmospheric components. There's no telling what new anomalies JWST might spot. It could pick up on exotic cosmic phenomena that point us down the path to understanding negative energy better. The real prize, of course, is the possibility of traveling to distant exoplanets in a fraction of the time we currently think is possible. Imagine being able to board a spacecraft, initiate a warp bubble, and arrive at Alpha Centauri in just a month by the clock on the spaceship. That might allow us to set up outposts or fully crewed missions far beyond our solar system. It would open a new chapter in human history, one in which space colonization becomes more than just a science fiction fantasy. The whole idea raises countless questions. What would such journeys cost? How would we power these drives without draining entire stars? Would we inadvertently disturb the local environment of the star system we're traveling to? And of course, there's the philosophical and ethical question of encountering alien life, if any exists. If we can cross interstellar distances quickly, we might one day meet life forms that are entirely outside our imagination. This dream might still be far away, but hope often comes from unexpected corners. Even the accidental detection of a microscopic warp bubble is a landmark event if it holds up under scrutiny. It's an example of how scientific progress works. We start with a wild idea, we test parts of it in the lab, and sometimes we get results that lead us down entirely new paths of discovery. We shouldn't forget that many ideas once labeled impossible or fringe were gradually accepted as scientists gathered more evidence. Airplanes, computers, nuclear power. These all began as nearly inconceivable concepts that are now part of everyday life. Perhaps one day the notion of a warp bubble will join that list. Still, plenty of challenges stand in our way. One is the engineering side. Even if we confirm negative energy in small experiments, scaling that up to a craft capable of carrying humans is a colossal leap. We'd need materials that can handle the stress of space-time distortions. We'd also need to figure out how to protect travelers from cosmic radiation and how to navigate safely while bending space around us. Another challenge is energy consumption. The early Alcubierre drive concept required more energy than the mass of the universe, which is not feasible. We might require advanced fusion reactors, antimatter, or something beyond what we have right now. There's also the matter of controlling these energies safely. If the negative energy field collapses or reacts in an unexpected way, the results could be catastrophic. Meanwhile, the James Webb Space Telescope serves as our cosmic lookout. It's capturing data on galaxies, quasars, and stellar nurseries across the universe. As it does so, we get a better sense of the raw materials that exist out there, the distribution of dark matter, the role of dark energy in the expansion of the universe, and the variety of exoplanet atmospheres. Each piece of information refines our understanding of the laws governing space. Maybe we'll see patterns in how dark energy stretches the universe that inform us about how to manipulate smaller pockets of space around a spaceship. Maybe we'll notice that certain cosmic events produce bubbles of space-time that mimic in some tiny way the warp bubble concept. There's a poetic aspect to all this. Humanity has always been curious, from building the first sailing ships to cross unknown seas to launching rockets to the moon. We've relentlessly pushed past frontiers. Now, at the cosmic scale, the James Webb Space Telescope stands as a symbol of our longing to see what lies beyond the horizon. Meanwhile, scientists try to rewrite the boundaries of physics to let us move beyond our own star. Put simply, it all comes down to our thirst for knowledge and our refusal to accept that we must remain forever confined to Earth. While we may not see a fully functioning warp drive tomorrow, the journey toward developing one is exciting. The smallest lab experiment can set off a chain reaction that changes everything. Maybe what's needed next is an unexpected observation from JWST or from a new type of particle accelerator here on Earth. Or maybe the next Einstein will come along with an even better equation for how to shape space-time to our advantage. Each new finding is a stepping stone on a path that could lead us to the stars. The real question is whether we can keep the public and private sectors interested in long-term research that may not yield immediate payoffs. Telescopes like JWST cost billions of dollars, yet they bring intangible rewards. They expand our sense of wonder, push the boundaries of human achievement, and lead to discoveries that can inspire new technologies. If warp drive research is to progress, it will need a similar level of commitment and patience. Nothing about bending space-time will be cheap or simple. It's the ultimate challenge in physics and engineering, and maybe in imagination, yet the excitement is palpable. Star Trek has featured warp speed since 1966, and generations have grown up dreaming about cruising through the galaxy. Science fiction often lights the spark, and serious science can sometimes fan it into reality. Warp speed, if ever attained, would forever change our species. We could spread out into the galaxy, choose from thousands or even millions of planets that might be habitable, and see with our own eyes whether life thrives in hidden corners of the cosmos. The timeline might be centuries, but the fact that we're making tiny steps forward means that the door to these possibilities isn't locked. It's just challenging to open. Perhaps the new wave of exoplanet discoveries will reveal worlds that look eerily like Earth. We might see signs of water, oxygen, or even biomarkers that suggest life. A place like that would become the ultimate destination for interstellar exploration. Imagine the day when images from the James Webb Space Telescope confirm an Earth-like exoplanet orbiting within the habitable zone of a star that's only a few light years away. Would we ignore that? Or would we intensify our research into warp bubbles to plan a journey? History suggests we do the latter, because the human story has always been about exploring new frontiers, whether crossing an ocean or crossing interplanetary space. A warp bubble is enticing because it could make interstellar travel possible within a lifetime. Unlike generation ships or cryosleep, both with major challenges, a warp bubble could cut trips to months. You could visit Proxima Centauri and return without losing years or leaving loved ones behind to age beyond recognition. Warp drive research isn't NASA's priority right now, with focus on missions to the Moon, Mars, and beyond. But NASA has a history of fostering visionary ideas. If JWST or other observatories uncover clues about negative energy, it could spark renewed interest in faster-than-light travel. Private companies already driving commercial spaceflight might see warp travel as the next frontier. We're at a pivotal moment in history. The James Webb Space Telescope is uncovering the universe's earliest secrets, while scientists like Dr. White are finding clues about negative energy and warp bubbles. These discoveries challenge our understanding of space and time. If proven on a larger scale, warp bubbles could revolutionize life as profoundly as fire, the wheel, or electricity. We must stay humble. The vastness of space makes even solar system travel a challenge, let alone interstellar journeys. The speed of light is a hard limit, but warp bubbles offer a clever workaround, distorting space-time to cover great distances without breaking physics. While the concept is brilliant, the engineering hurdles remain immense. Progress requires perseverance and investment in research. History shows that yesterday's impossibilities become today's breakthroughs. Splitting the atom once seemed like fantasy. Now we have nuclear power. Decades ago, instant global communication was unthinkable, yet now it's in our pockets. Warp bubbles might feel distant, but physics often surpasses even the boldest imaginations. Our next steps involve exploring the cosmos with tools like JWST, analyzing exoplanet atmospheres for signs of life, and studying early galaxies to refine our understanding of dark matter and energy. Each discovery could unlock secrets of warp drive theory, from negative energy fields to new physics that might solve faster-than-light travel. For now, we imagine starships launching toward distant stars and humanity becoming a multi-planet civilization. It sounds like science fiction, just like moon landings or Mars rovers once did. Every spark of curiosity can ignite a blaze of discovery. Warp bubbles, the James Webb Space Telescope, and exoplanet exploration are pieces of a grand puzzle, driving us to push boundaries and imagine a future beyond the speed of light. The more we explore, the more mysteries we uncover, fueling innovation and new frontiers. The universe invites us to keep questioning, discovering, and reaching for the impossible. Thanks for joining us on this journey through space and warp bubbles. If you enjoyed it, like, subscribe, and share your thoughts in the comments. Who knows, maybe you'll help make warp travel a reality. See you next time. As mentioned earlier, my partner Aura just launched their new Are You Smarter Than a Scammer? Quiz. Take the quiz and see if you're as savvy as you think. Link in description.
There are telescopes searching the skies for signals, for hints, for a sign of civilizations, or even the signals from starships moving through the sky.
Imagine a powerful laser beam racing across space and striking Earth from a spot 10 million miles away. Scientists are in shock. How could a transmission so precisely travel such vast distances? Is it a curious natural event? Or does it mean someone out there is trying to reach us? This video explores the details behind the shocking beam and why it could reshape our cosmic future forever.
Amazing breakthrough by NASA. A laser beam sent from 10 million miles away in space has arrived at Caltech's Palomar Observatory near San Diego.
The unprecedented laser signal. Scientists worldwide have studied electromagnetic signals for decades, but a direct laser beam from 10 million miles away stunned everyone. This distance, although huge, is relatively close in cosmic terms. Researchers noticed an intense burst of energy, different from typical radio waves or X-rays. The beam was narrow, with a frequency that implied precision. That alone raised questions. Could a natural cosmic process create such a focused signal, or was it deliberately aimed at us? At first, some experts wondered if it was a glitch in the instruments. Others suggested a rogue satellite beam or reflection from space debris. Yet follow-up data revealed the same signature across multiple observatories. This consistency dismissed equipment errors or random interference. The core question became whether we faced a rare cosmic outburst, like a star shedding matter in a precise burst, or evidence of intentional messaging aimed at Earth. The beam's detection method also raised interest. Researchers used optical telescopes combined with sensitive detectors that specialize in laser scans. Each device confirmed the beam's coherence, which implies it stayed tight over distance instead of scattering like normal light. While cosmic lasers do exist in nature, they rarely remain that focused. Many scientists think advanced technology might be responsible. If so, we face a groundbreaking event that could change our views on interstellar communication, resource sharing, or even the possibility of contact. Some argue we must tread carefully before we respond, fearing unknown risks. Others say this might be our best chance to learn if we share the cosmos with other life. Competing theories are emerging. A few researchers suggest a natural laser phenomenon linked to specific stellar processes. They cite certain variable stars that can generate sharp emissions under rare conditions. Those events usually display wider beams or shifts in frequency. Our laser signal maintained a stable profile, hinting at a more deliberate source. Another idea involves a hidden probe stationed near our solar system, firing a test beam. Skeptics insist we need more evidence. They note that space is vast and unexplored, meaning unusual signals can come from lesser-known cosmic objects. Still, the precise structure of this beam stands out. Scientists plan to organize more observations to confirm its origin and track any repetition. If they find a pattern or coded pulses, Earth might be on the brink of a momentous discovery about life beyond our planet. Such a breakthrough would forever transform our place in creation. Could this mysterious beam be a cosmic greeting, or is it a warning from afar? Possible sources and early hypotheses. Once news spread of the strange laser, multiple ideas surfaced. One proposal blames a hidden comet or asteroid that reflected sunlight in a narrow band. Critics say such an alignment would be extremely rare. Another argument sees it as a secret experiment by an Earth-based group testing advanced communication. If that were true, you'd expect formal notices, or at least hints from agencies. So far, no official statements support these explanations. Speculation about extraterrestrial involvement grew stronger when astronomers matched the signal strength with estimates for interstellar messaging. A beam of this power would be easier to send if you had advanced technology. Some wonder if an intelligent species might have noticed Earth's radio leaks over the last century and decided to respond. They point to our many broadcasts drifting outwards, like invitations to anyone who can detect them. Did someone finally answer? Still, many scientists keep a cautious view. They recall past anomalies that led to wild claims but turned out to be natural. The famous "wow" signal, for example, stirred talks of aliens until comets were proposed as a cause. Yet the debate stayed unresolved. In this case, the beam's targeted shape stands out. Natural sources are often broad or unstable. This signal's clarity suggests a sender using advanced methods or an incredibly rare event. A leading hypothesis proposed that an unknown cosmic event generated this laser briefly, and we happened to catch it. Gamma-ray bursts, magnetars, or black hole flares might release high-energy beams, but they rarely showed the coherence traits we see here. Another angle involves the possibility of a hidden craft. If a probe is hovering beyond our orbit, it could produce a laser for communication or navigation. Yet we lack direct proof of such an object. Scientists agree more observations are crucial. They plan to observe the region again at different times and wavelengths. If the laser repeats or shows slight changes, that data may confirm patterns tied to technology. Meanwhile, smaller observatories worldwide are preparing to scan the same patch of sky, hoping to see hints of movements or shifts in frequency. If we can match the signal's timing with the known cosmic occurrences, the natural theory gains strength. But if it remains constant and directed, support for an intelligent source grows. For now, experts hold onto both possibilities, waiting for more clues to reveal which path best explains this early puzzle. Either way, this mystery captivates our imagination. Keep watching, one tiny clue could flip our theories and spark cosmic answers soon. The science of laser transmissions. Lasers differ from radio waves because they can stay concentrated over huge distances. When scientists send a laser beam, the light does not spread out as much, so more power reaches its target. In an interstellar context, this means a civilization could send data across many light years without losing clarity. Radio signals, while easier to produce, often become weak and scattered. That is why some experts think advanced societies would use lasers for messaging. Such beams also allow for higher bandwidth. In theory, you could embed enormous amounts of information inside a laser. If a distant group wanted to share complex data, like images or scientific insights, lasers would make sense. These beams are precise, so they reduce accidental exposure to other systems. That could be helpful if someone wants privacy. On the other hand, building a massive laser device demands huge energy. We are still learning how feasible that might be. Scientists note that natural cosmic lasers called masers have been observed in star-forming regions. These involve molecules like water or silicon monoxide amplifying microwaves. But a full-blown laser beam from space is rarer. Most known cases are faint or like the tight focus we see in artificial lasers. This is why the new detection stands out. If it is not an advanced civilization signal, it must be an exceptional natural event we have never documented. Optical SETI programs have looked for signs of alien lasers for years. They scan the skies, hoping to catch short pulses or flashes. Some telescopes combine optical detection with spectrometers to measure frequencies that hint at artificial sources. When a spectrometer sees a spike in a narrow band, it triggers an alert. We can then compare that data with recordings from other sites. A genuine signal should appear at multiple locations, ruling out local errors. Researchers also factor in cosmic dust, gas, and gravitational fields that might bend or dim the beam. If the signal remains robust after traveling 10 million miles, it must be produced with intent or arise from a power source we barely understand. The timeline is equally important. A laser could be fired in short bursts, waiting for detection, or it might run continuously, hoping someone stumbles upon it. We have more tools than ever to investigate. Future telescopes equipped with advanced optical sensors can refine our search, revealing whether the signal is a one-time oddity or a turning point in cosmic communication history. Hope awaits discovery. If aliens prefer lasers, are we finally witnessing their interstellar spotlights aimed right at Earth? Historic cosmic clues and context. Strange signals from space are not new. Decades ago, scientists were baffled by the WOW signal, which lasted just over a minute. Nobody confirmed its source. Some pinned it on comets, while others said it might be something else. Fast radio bursts have also puzzled us. These bursts are short but powerful, seeming to come from distant galaxies. They sometimes repeat, hinting at an unknown energy process or an intelligent attempt to broadcast cosmic beacons. Other incidents have popped up, like unexplained radio waves near the center of our galaxy. One event repeated a few times, then vanished. Astronomers struggle to match it with known celestial objects. Some suspect a rotating star or a magnetar in a weird phase, but no conclusion has emerged. These mysteries teach us to be open-minded. Many signals remain unverified, leaving the door open for extraordinary explanations, including advanced civilizations sending coded greetings. Before radio astronomy, people saw odd lights or patterns in the sky, often linking them to legends or spiritual events. With modern instruments, we realize many were comets, auroras, or meteor showers. Yet some sightings defied easy labeling. Today, the search for cosmic anomalies include wide-spectrum scans. From radio to infrared, each discovery broadens our view, showing that space holds more surprises than we ever imagined. Some are natural wonders, but others defy easy explanations. When signals like this laser appear, historians of science recall how we once confused pulsars for alien beacons. Early data was so strange that the discoveries named them LGM, short for Little Green Men. Later, we learned they were rapidly spinning neutron stars. This lesson reminds us that bizarre phenomena can have natural causes, but it also encourages us to keep looking. If we dismiss every unusual signal, we might miss proof of other life. These events add context to our laser discovery. Each unexplained signal led to deeper research, better tools, and more open minds. This time, the laser's sharp focus sets it apart. Experts have compared with historical records of cosmic flares, supernova remnants, or exotic star behavior. If none match, the notion of an intentional sender gains ground. Even then, we might struggle to confirm it without repeated signals or more data. Still, curiosity pushes us forward. History shows that big revelations often begin with small anomalies. Our next step could be the biggest leap yet, uncovering cosmic neighbors we once only dreamed about. We watch with eager hope. Could this new laser mark the next wow moment that finally confirms cosmic kinship exists? Decoding the message, methods, and challenges. If this laser carries a message, decoding it is not simple. Scientists would look for patterns such as repeated sequences, prime numbers, or pulses that indicate an intelligent design. They might convert the signals into binary or analyze changes in intensity. Any sign of deliberate structure could be huge, but if the beam is just a steady wave, it might offer fewer clues. Researchers often compare multiple datasets to confirm that nothing was lost. Mathematics is a universal language. So many think aliens would use it. Prime numbers are a favorite choice since they do not appear naturally in large sets. Simple shapes or even short sequences that match geometric forms could be embedded in signal spikes. On Earth, we have sent messages like the Arecibo transmission, which used binary to outline basic human information. In the same way, an incoming laser might hold its version of a greeting. However, a big challenge is ensuring we interpret any code correctly. If advanced beings use concepts we do not recognize, we could miss the meaning entirely. We might see patterns but misunderstand their purpose. Also, cosmic noise or interference can distort signals. A slight frequency shift might erase key details. Scientists must gather extensive data to filter out random spikes. The risk is that we might dismiss a real code or falsely confirm nonsense. Some experts propose turning to machine learning, algorithms that can spot subtle patterns that humans might overlook. By training these systems on known signals, we can quickly flag anomalies. The downside is that machines can also produce false positives if not carefully calibrated. Another idea is to share raw data with the global science community. Thousands of volunteers could analyze slices of the signal, similar to how citizen scientists help classify galaxies. If the laser does hide a message, the content could range from a simple hello to complex data dumps. It might share knowledge, point to a star system, or even ask for a reply. The biggest hurdle is proving that any pattern is intentional and not random. Repeated signals would help, as they reduce the chance of coincidence. Even if we find strong evidence, global consensus might be slow. Some will stay skeptical, others will push for immediate contact. Decoding a true extraterrestrial greeting would be a milestone in human history, bridging science, philosophy, and our sense of identity under one vast cosmic umbrella. We stand on history's threshold. What if we're reading an alien handshake but cannot recognize their welcome just yet? Reactions on Earth, from governments to the public. When reports of a possible alien laser surfaced, world governments took notice. Some agencies quietly convened task forces to examine the data. They worried about national security, fearing advanced technology might pose unknown dangers. At the same time, scientific bodies encouraged open collaboration to confirm the signal's nature. This tension reflects an old debate: keep discovery secret to avoid panic, or share findings to unite people in a moment of global wonder. Religious groups also reacted. Leaders met to discuss how contact or even the possibility of it fits with their teachings. Some saw it as a sign of cosmic harmony, while others viewed it cautiously. Public sentiment ranged from excitement to anxiety. Some folks online celebrated a chance to learn from more advanced beings. Others worried about invasion scenarios, fueled by science fiction. Hashtags trended, with debates over whether humanity should respond or stay silent. Meanwhile, top scientists cited existing protocols, like the SETI post-detection guidelines. These suggest verifying the signal, informing global bodies, and discussing the next steps together. No single nation owns the sky, so any confirmed contact would be a shared event. That said, cooperation is not always easy. Powerful nations might try to gain a strategic edge, seeking to decode the laser first. Skeptics also argued the entire claim might be hype, calling for patience and proof. Public demonstrations spread in major cities, with people holding signs that read, "We are not alone," or "Protect Earth first." Broadcasters hosted panels featuring scientists, philosophers, and even sci-fi authors. Some experts said we could gain unity if the signal is confirmed. Others warned that fear or misunderstanding could fuel conflicts. The biggest question was how to handle the unknown. A confirmed alien signal might unify humanity like never before, but it could also divide us. In some circles, speculation grew about immediate diplomacy. Should we send a reply? Would we risk revealing our level of technology or location? Scientists recalled Stephen Hawking's caution about announcing ourselves to unknown life. Others said staying silent might be missing a chance at cooperation or guidance. In any case, the wave of interest has boosted research, funding, and inspired new space partnerships. Many now see Earth's future tied to the outcome of this discovery. If the laser is real and from another mind, it might reshape our global identity. In that sense, the biggest reaction on Earth is hope mixed with awe. Potential contact stands within our grasp. Are we ready to greet cosmic visitors, or will fear overshadow wonder if they arrive? Looking ahead, future of cosmic messaging. This laser event might spark new funding and collaboration for advanced sky surveys. Scientists plan larger telescopes with ultra-sensitive detectors to cover visible, infrared, and ultraviolet bands. Projects like the Square Kilometer Array and next-generation space observatories could confirm if similar signals exist elsewhere. Private companies might join, hoping to claim a role in potential first contact. With more eyes on the skies, the odds of spotting repeated beams or related phenomena will increase. New propulsion ideas might also emerge. If we suspect that advanced civilizations use lasers for communication or even travel, we may invest in laser-driven spacecraft. Concepts like light sails, pushed by powerful laser beams, have been proposed. Though still theoretical, they could allow faster movements between star systems. Governments and private groups inspired by the possibility of meeting neighbors might rush to develop these technologies, leading to a leap in off-world transport. Debate continues about sending our laser messages. Some say we should let others find us first, given the risks Hawking warned about. Others believed open communication fosters trust. If we never respond, we might miss alliances or knowledge that could help us. Nonetheless, any decision demands global agreements. Since the stakes affect everyone, international panels might form to set protocols for what we say, how we say it, and when to send it. Future missions could also include specialized probes that scan deep space for similar lasers. These crafts would carry advanced optics and onboard AI to spot signals we miss on Earth. They might orbit beyond Pluto, reducing interference from solar radiation. Once we confirm a laser's origin, we could aim follow-up beams or send drones to investigate. It sounds like science fiction, but so did spaceflight centuries ago. Each step forward began with curiosity. Our planet may never be the same if this laser signal proves real. Whether it's a cosmic greeting or a fluke of nature, the questions it raises are enormous. Will we soon confirm that we share the stars with other minds, Or will further data show a mere abnormality of physics? Either way, our thirst for answers grows. Please like, subscribe, and share your thoughts. Join us as we keep watching the skies and imagining new frontiers ahead. The universe beacons us onward.
There's nowhere on Mars where there isn't ready dust and sand to add to that storm. So these storm systems can kick up and last weeks.
NASA's rover sent back a startling Mars photo that might change how we see the red planet. It shows something so unexpected that scientists cannot agree on its origin or meaning. Want to know how this single image could reshape our future on Mars? Keep watching to learn more about this mystery that might forever rewrite our understanding of the red planet.
Once again, for a look at some of the day's more interesting stories, and we begin with a big day for space exploration.
NASA's rover overview. NASA's rover missions have changed how we explore Mars. From the early Sojourner in 1997 to the advanced Perseverance rover today, these robotic travelers have helped us learn about the planet's rocky terrain, thin air, and past water flow. Each rover brings cutting-edge tools to gather data and beam it back to Earth. Perseverance, which landed in Jezero Crater in February 2021, focuses on finding clues of ancient life. It carries cameras, sensors, and a drilling system that can collect samples. These samples may one day come back to Earth through planned return missions. By studying them in laboratories, scientists hope to confirm if Mars once supported microbial life. This rover also features a small helicopter named Ingenuity. This pioneering craft has shown how flights on Mars is possible despite the planet's low air pressure. Even though Ingenuity's main role is to test flight feasibility, it has helped Perseverance navigate by scouting nearby terrain. The synergy shows how NASA designs new missions with multiple goals, from pure exploration to practical support. Curiosity, which landed in Gale Crater in 2012, continues to send data about the planet's geology. Its work laid the groundwork for Perseverance, revealing that Mars was once wet and possibly habitable. While Curiosity still roams, Perseverance pushes further by hunting for signs of ancient organisms. The two rovers complement each other, giving us more clues about Mars' history. Rovers also act as Mars weather stations. They track dust storms, temperature shifts, and wind patterns. This helps scientists forecast future conditions and plan safe landings. In turn, mission planners learn how to protect equipment from the planet's harsh environment. At the heart of every rover mission is the drive to expose mysteries hidden in Mars soil and rocks. As each rover outlasts its initial goals, we gain deeper insights into a world that could help us understand our origins. Wait until you see why this image left NASA confused. The mystery image. The newly captured image that caused such a movement shows an odd shape jutting out of the Martian surface. At first glance, it looks like a tall, thin pillar rising from the red soil. The rover spotted it during a routine survey near a rocky outcrop. When mission control saw the raw data, they realized this is not an ordinary rock formation. What makes this image special is the sharp contrast in color and texture compared to the other surrounding terrain. While most rocks in that region appear rough and dull, this feature looks smoother and slightly reflective. Some team members suspect it could be a chunk of layered rock carved by ancient winds or water. Others think it might be a piece of meteorite that impacted the planet long ago. NASA's initial reports mentioned the possibility that this feature has a hollow interior. Images from different angles suggest an opening or gap near its center. That alone raises exciting questions. Could water have once seeped through this rock, leaving a cavity behind, or did volcanic activity shape it millions of years ago? The rover's instruments have been busy collecting close-up views and chemical readings to answer these questions. People around the world have theories too. Some say it looks artificial, like a sculpted monument. Social media lit up with claims ranging from alien technology to hidden entrances. NASA scientists caution against jumping to wild conclusions, reminding everyone of the power of natural forces on Mars. The planet's harsh weather, ancient volcanic eruptions, and possible water flow have created many strange shapes over time. A crucial aspect of this mystery is timing. The rover captured the image just as dust levels were dropping, providing an unusually clear view. A few days earlier or later, the object might have remained hidden by swirling sand. This perfect window allowed cameras to snap pictures of details that might have gone unnoticed. The shape's height is another point of debate. Estimates put it at about 1 meter tall, though exact measurements must await for more data. If it proves stable enough, the rover might approach closer, but every step on Mars must be planned carefully to avoid hazards. Loose sands can trap wheels, and hidden cracks can endanger the rover's instruments. Another twist is the unusual reading from the rover's spectrometer. Early data hints at mineral compositions not commonly seen in that zone. This puzzle deepens the drama, making the team wonder if there's a link to underground processes. Could this be part of a buried lava tube, or is it a leftover from a time when water carved out cavities? So far, NASA has published a few high-resolution images, but the real analysis is ongoing. Experts need time to interpret the rover's findings, run simulations, and compare them with known Martian geology. Everyone agrees that patience is key, as rushing can lead to wrong assumptions. Curious what NASA scientists said when they first saw this odd formation? Let's see their immediate reactions next. Inside NASA's reaction. Once NASA's science team reviewed the raw images, a wave of excitement spread across the control room. Researchers zoomed in, adjusted lighting, and debated if the odd shape could be a trick of perspective. Some compared it to unusual rock spires seen in other Mars missions, while others emphasized its unique smoothness. Even the slightest difference from known formations can hint at a fresh discovery. The first internal memo described the formation as a high-priority curiosity. This meant the rover's schedule might shift to gather extra photos and data. A few team members asked if this could be evidence of a past environment with stable water. Others wondered if it might mark the site of a rare mineral deposit. In any case, the team knew they had stumbled upon something that deserved closer study. Phone calls and messages flew among key scientists in different time zones. Specialists in Martian geology offered their opinions, comparing these images with the known volcanic remnants. Paleontology experts also joined the conversation, hoping to spot any patterns that might connect with microbial life. The debate grew, but excitement stayed high. While public curiosity soared, NASA kept a calm, methodical approach. They reminded everyone that Mars is full of surprises. Over the years, illusions and shadows have tricked even seasoned observers. Yet, they also agreed that ignoring odd formations is risky. If there is even a slight chance of finding proof of ancient life, they must investigate. Mission managers considered rerouting the rover, but each decision had risks. A closer look might reveal delicate structures that could break if disturbed. The rover's wheels must avoid soft terrain. In the end, the team decided on a cautious path to approach the formation from a stable angle. Extra days would be added to confirm the plan. No immediate press release followed. Instead, NASA chose to gather more facts before making bold statements. This approach mirrored past experiences where early headlines confused. They wanted data from every available tool: cameras, spectrometers, and environmental sensors. Only then would they share a more confident assessment. Some insiders even joked that this could become 2023's Martian riddle, yet all agreed it was worth pausing routine plans to focus on this new curiosity, hoping to unlock another piece of Mars' puzzle. Keen to find out how this odd finding compares to past Mars surprises? Next, we'll look at other strange moments in Red Planet history. Historical Mars surprises. Mars has a history of tricking our eyes. One famous case is the face on Mars, spotted by Viking 1 in 1976. That photo showed a hill that looked like a human face. Many people jumped to alien theories, but later, better images revealed an ordinary mesa shaped by shadows and light. The lesson was clear: illusions happen often on this planet. Another shock came when orbiters spotted dark streaks on crater walls. At first, some believed these streaks to be liquid water flowing on modern Mars. NASA took a closer look and concluded that they might be caused by salty brines or shifting sand. Even now, the debate continues, reminding us that each discovery demands more data and patience. In 2008, the Phoenix lander stirred when patches of bright material were found that had vanished after a few days. Scientists realized it was likely ice sublimating in the thin air. This direct observation of water ice near the surface hinted at Mars' chilly but watery past. people began wondering if microbes could survive in hidden icy pockets. Curiosity also made headlines in 2014 by detecting sudden spikes in methane. On Earth, methane often comes from living organisms, but it can also form through chemical reactions underground. The spikes sparked lively discussions about whether something was active below Mars soil. Further measurements have been inconsistent, leaving the methane mystery unresolved. In 2019, the InSight lander detected Mars quakes, proving the planet is not entirely dormant. Seismic vibrations pointed to geological activity deep inside. This was a surprise for those who viewed Mars as a frozen wasteland. The quakes may help us learn how the planet formed and whether it still has pockets of magma. Shifts below the surface could also shape odd rock forms at times. Dust devils provide another example of unexpected Martian events. These swirling columns of dust can tower for kilometers, sometimes cleaning rover solar panels by accident. While they help rovers in that sense, they also stress Mars' unpredictable climate. Even the famed blue sunsets discovered by Spirits and Opportunity raised eyebrows. The thin air and dust particles scatter red lights more than blue, making the sky look reddish during the day and bluish at sunset. This upside-down effect compared to Earth's sky is yet another sign of how alien Mars can be. Think it might hint at ancient life? Let's see what the experts believe. The search for past or present life. Images like the one the rover just sent fuel our desire to find out if Mars ever hosted life. Scientists look for features that hint at water, since water is a key ingredient for life as we know it. Over time, evidence has mounted that ancient rivers, lakes, or even shallow seas once dotted the Martian surface. One way to spot past water activity is through minerals like clays and sulfates. These form in wet environments, locking in chemical signatures of those conditions. When a rover's camera detects these minerals, researchers grow hopeful. They know each sample might hide organic molecules, tiny carbon-based compounds that could reveal life's early building blocks. NASA also keeps an eye out for structures called stromatolites, which on Earth come from microbial communities layering minerals over time. If something like that appears in rover images, it would be huge news. So far, no definitive evidence exists, but the search goes on. Sometimes, odd rock shapes raise the question, could this be a fossil? Mars is harsh, with temperature swings and constant radiation. That said, if life ever evolved there, fossils might remain hidden beneath the surface or locked in protective caves. Rovers like Perseverance carry jewels to sample rock cores, hoping to catch any trapped clues of ancient life. The possibility of present-day life, even if microscopic, also drives mission goals. Special cameras and instruments check for methane spikes or other gases linked to living organisms. These bursts could come from geothermal reactions or unseen microbes. Finding a consistent, repeating pattern would be an incredible find. Scientists remain cautious. They recall how Viking landers in the 1970s produced ambiguous data about microbial life. Some experiments hinted at biological activity, but others disagreed, leaving the question open. That experience taught NASA to test thoroughly and consider non-biological explanations. Today's advanced rovers have better tools, yet the final proof of life would likely require return samples or a human-led mission with full lab gear. For now, the images they beam back are our main guides, letting us guess which spots deserve deeper study. Each strange feature could be a stepping stone to the biggest discovery of our time. Wondering how NASA processes and interprets these pictures? Tech and tools. How NASA analyzes rover imagery. NASA relies on a complex system of cameras and sensors to interpret what rovers see on Mars. For example, Perseverance uses Mastcam Z, a zoom-capable camera that offers panoramic and stereoscopic views. This helps mission planners gauge distances and identify points of interest. Another key tool is the SuperCam, which fires a laser at rocks to reveal their composition through vaporized material. Every bit of data is compressed for transmission because of limited bandwidth. The Deep Space Network, a global system of radio antennas, receives the signals. Once the images arrive, they undergo calibration to adjust for color shifts caused by Mars' thin air and dust. scientists also correct for distortions from the camera's lens. Advanced software then steps in. Machine learning routines flag shapes that might deserve a closer look. This saves time for the human experts, who can focus on unusual details. However, final judgments still require human eyes, especially for subtle clues like slight variations in texture or faint color traces. In some cases, NASA merges data from different instruments to form a fuller picture. For instance, combining high-resolution photos with spectrometer results can confirm if a rock has specific minerals. If the spectrometer sees signatures of water-related compounds, the team might command the rover to drill a core sample in that spot. The images are shared with scientists worldwide, many of whom volunteer to classify or examine certain features. This collaboration increases the chance of catching rare details. The pace of discovery can be fast, with updates posted daily for the public to see. NASA hopes openness will spark more interest in Mars exploration. These tools and methods do more than produce pretty pictures. They are the eyes and ears guiding each rover's path, from avoiding hazards to uncovering new targets. Imaging stands at the core of every decision made on Mars. Without it, the rovers would be blind, and we would lose our best link to the red planet's secrets. How might this shocking image shift plans for future missions? Next, we'll see why a single photo can alter the course of Mars exploration. Potential impact for future missions. A single image can shift an entire mission's priorities. If NASA's team thinks this formation could hold signs of past water or rare minerals, they may direct more of the rover's time toward it. That could mean fewer scans of other sites, but it also raises the chance of a breakthrough. Researchers always weigh the risk of missing out on other goals against the potential reward of a major find. For missions beyond Perseverance, unexpected photos can change design plans. If data suggests that certain rock types hide key clues, future rovers might carry specialized drills or advanced cameras. They might also include better wheels for rough terrain. Each discovery teaches planners how to adapt technology for Mars' extreme challenges, from dust storms to temperature swings. Human missions could also be affected. NASA and partners plan to send astronauts to Mars, possibly in the 2030s or 2040s. If images hint at resources like ice near the surface, that spot might become a candidate for a future base. Ice could provide water for drinking, oxygen for breathing, or hydrogen for fuel. Detailed visuals help narrow down safe and resource-rich landing zones. Sometimes, a puzzling image sparks collaboration with other space agencies. The European Space Agency or private outfits may share data or develop joint missions. Everyone wants to avoid duplicating work and expand knowledge faster. A single photo can act like a magnet, drawing in more scientists, engineers, and funding. Public engagements also swells. When a mysterious picture surfaces, interest in Mars exploration spikes. Students might focus on planetary science, or inventors might dream up new rover concepts. NASA often uses such buzz to highlight the value of space research. These discussions can influence budgets and keep Mars missions at the forefront. Finally, each surprising discovery sets the stage for bigger questions about life's resilience. Could hidden pockets of water exist? Is there an underground habitat? Are we seeing signals of lost ecosystems? Even if the answer is no, every test refines our methods and deepens our understanding of planetary evolution. In short, one photo can reshape strategies, draw global attention, and spark the next wave of exploration. The new Mars image has sparked questions that could lead to breakthroughs. While NASA tests samples and reviews more data, the world watches, hoping for answers about our cosmic neighbor's secrets. Did we glimpse proof of ancient water, or something even more intriguing? Time and research will reveal the truth. Until then, keep following these missions and join the conversation. Like, subscribe, and share your thoughts about Mars' latest mystery. Who knows what we'll discover next on the Red Planet?
We are one step closer to answering the age-old question, are we alone in the universe?
NASA has captured images that nobody expected to see. Each clip raises new questions about space, from bizarre solar flares to puzzling shapes on distant worlds. Could these findings hide clues about life on Mars or powerful forces at work on the Sun? We will dive into these surprising discoveries, from a giant pyramid-like structure in the asteroid belt to cosmic creatures that defy logic. Brace yourself for the unknown. Solar marvels. One of the most dramatic sights NASA recorded involves the Sun, the star that fuels life on Earth. It behaves like a constant nuclear engine, shining lights across the solar system. Yet, massive coronal mass ejections, or CMEs, are hidden beneath the steady glow. These fierce bursts occur when twisted magnetic fields suddenly hurl charged particles out into space. The Sun, made of plasma, is neither solid nor gas. It is a unique state of matter where electrons break free from atoms. During a solar outburst, millions of tons of superheated plasma can surge from the Sun's surface at extreme speeds. Sometimes these charged particles, carried by the solar wind, glide harmlessly through space, but other times they head toward Earth. If that happens, we see geomagnetic storms that can trigger vibrant auroras or interfere with power grids, satellites, and radio signals. Such events show how dynamic our Sun is. NASA's dedicated satellites, like the Solar Dynamics Observatory, keep watch around the clock. They track swirling loops of magnetic energy, capturing fast ejections that leave the surface. These missions also reveal how hot plasma loops expand and contract, forming giant arcs that can dwarf Earth many times over. By studying these recordings, scientists hope to predict big solar storms that might pose risks to technology. Each successful forecast helps operators power down vulnerable systems or reorient satellites, sparing us from harmful disruptions. Even though we often think of the Sun as calm, footage of violent flares reminds us how intense it can be. Charged clouds might tear away from the corona, creating bright flashes visible in extreme ultraviolet imagery. When that hot material loops back and crashes onto the solar surface, it sparkles like fireworks. The raw power on display highlights just how small we are in comparison to the star we rely on for warmth and energy. Researchers keep improving ways to model these eruptions. Advanced computer simulations show how twisted magnetic ropes can snap, releasing bursts that cross millions of miles in mere hours. NASA's cameras have caught swirling jets, shock waves, and complex patterns in the plasma. These details confirm that the Sun's activity is not random, but follows cycles tied to shifting magneticism. As we learn more, we sharpen our ability to protect Earth from solar hazards, ensuring that these mighty eruptions only dazzle us from a safe distance. Could a single colossal flare someday disrupt our world more than we ever imagined? Mysteries on the Red Planet. Mars has always drawn our curiosity, and NASA's images often hint at something more than a barren desert. Recent pictures captured dark streaks running down steep slopes, stirring debates about flowing water or salt solutions just beneath the surface. Scientists studying these lines discovered hydrated minerals tied to seasonal temperature shifts, raising questions about life's potential. Some hope these streaks mean Mars once had rivers. Others remain cautious, pointing out that brines may appear for short periods without forming stable habitats. Still, the possibility of hidden oases lingers. NASA's orbiters and rovers continue to send back high-resolution footage, sometimes revealing odd shapes that spark talk of Martian creatures or alien structures. While mainstream researchers attribute most weird forms to erosion, shadows, or dust devils, a share of observers believe we're missing key evidence of advanced life from ancient times. Another puzzle is the rumored salt lake beneath Mars' southern polar cap. Radar data suggested an underground reservoir, fueling speculation about bacteria surviving in briny pockets. If proven, that would be a giant leap for astrobiology. Yet follow-up studies cast doubt, implying we should gather stronger proof before concluding life thrives beneath the ice. Either way, these findings keep Mars at center stage in the quest to find life beyond Earth. Private companies also plan Mars missions, hoping to send humans soon. The rocky terrain, thin air, and extreme cold pose challenges, but data from NASA rovers help future explorers prepare. Some see a future colony fed by local ice and shielded from radiation under Martian soil. If modern-day flows exist, they might ease the task of setting up outposts. Astronauts could tap local water sources to grow crops or produce oxygen. Even rumors of tiny microbes spark excitement, since any living forms would reshape our sense of life's reach in the cosmos. Is Mars simply waiting for us to uncover its hidden streams? Or are we chasing illusions in the desert? NASA's continued surveillance guarantees more clues will emerge. Each new snapshot either reinforces the idea of past water or raises fresh doubts. But interest in the red planets never fades. Students, Hobbyists and scientists alike await more pictures, analyzing every ridge or channel for signs of something extraordinary. Whether real rivers once flowed or not, Mars remains a prime target for exploration. The path to answers might be long, but each clue pushes us forward. Can tomorrow's rover image finally confirm life? The pyramid planets and asteroid belts oddities. Beyond Mars lies the asteroid belt, filled with rocks and fragments left over from solar system formation. Among them is Ceres, a dwarf planet first seen in 1801. Though smaller than Earth's moon, it claims the title of the largest object in our region. NASA's Dawn spacecraft arrived in 2015, capturing strange close-up views that triggered curiosity. One highlight is the 3-mile-high mountain shaped like a pyramid, jutting upward from otherwise flat terrain. Scientists expected battered craters, but not a lone peak with steep sides. To this day, experts debate whether it formed through cryovolcanic activity or some other process. One side appears brighter, reflecting sunlight in a way that draws attention from orbit. At the same time, Dawn's instruments detected weird bright spots inside certain craters. Early speculation suggested ice, but data hinted at salt deposits, possibly left over from subsurface brines that erupted and evaporated. This means Ceres might be more active than once assumed, with pockets of fluid beneath the crust. The presence of salt raises the idea of a hidden ocean that froze long ago, leaving brine reservoirs behind. If so, Ceres may belong to the list of ocean worlds in our solar system, along with Europa, Enceladus, and Titan. Some experts guess that microbial life could once have emerged if conditions were right. While no proof of biology exists, the puzzle remains open. As for the pyramid-shaped feature, it continues to fascinate watchers. Its slopes are smoother than typical crater walls. Images also reveal potential fractures or ridges, leading some to label it a dome. The question lingers: did internal pressures push up this mountain, or was it shaped by impact over time? Dawn's mission ended in 2018, but the trove of data still fuels fresh studies. Models propose that cryovolcanism might reshape the surface at slow rates. Another idea is that collisions with asteroids expose deeper material. Each clue points to Ceres as more than just a dull rock. Surprises from Ceres remind us our solar system holds countless oddities, intriguing shapes, bright spots, and possible hidden water challenge old views of these smaller bodies. Maybe the asteroid belt itself hides further marvels, awaiting the next spacecraft to arrive and capture even more shocking footage. With each photo, NASA shows us that surprises do not lie only on Mars or the outer planets. Could one hidden ocean in the asteroid belt hold more intrigue than we ever guessed? The lonely pyramid on Ceres just might be the start of deeper discoveries to come. Astonishing astronaut moments. While robotic probes reveal distant secrets, astronauts living in orbit capture equally surprising footage. Seeing a crew member struggle to walk after months in zero gravity feels surreal. One NASA astronaut recorded himself attempting simple steps upon return, swaying side to side, fighting to keep balance. Weightlessness causes muscles and bones to weaken, making normal movement tough after touchdown. Another dramatic scene belongs to Bruce McCandless, who performed an untethered spacewalk using a manned maneuvering unit. Watching him drift hundreds of feet from the shuttle with no cords or cables is breathtaking. Tiny nitrogen thrusters allowed precise adjustments, but the risk was undeniable. Yet this demonstration paved the way for greater confidence in external repairs and satellite retrieval. Humor also emerges in NASA's orbit footage. Astronaut Scott Kelly, for instance, once donned a gorilla suit, chasing his colleague through the station's narrow modules. That lighthearted clip showed how crucial morale is in cramped quarters, far from Earth's usual comforts. Moments like this, caught on camera, remind us that astronauts remain human despite working in extreme conditions. Physical demands stand out when you see how space affects the body. Long missions alter blood flow and fluid distribution, sometimes impacting vision or heart health. NASA invests in special exercise devices and daily routines to reduce harm. Each new video from the ISS underscores the complexities of living without gravity. Basic tasks like sleeping or washing become new puzzles. Still, these clips inspire us. We watch with awe as people float through modules, fix equipment, or share meals in microgravity. The entire station is a laboratory of motion, where walls and ceilings are meaningless. Every corner might hold a camera capturing feats no one thought possible decades ago. To Mars missions aim for longer stays on the Moon or even Mars, meaning these insights will shape how we adapt to harsh conditions. By sharing raw footage, NASA reminds us that each flight is both scientific progress and a grand human experience. Could we handle the same extremes if we took that small step ourselves? Cosmic creatures and unexpected finds. Strange discoveries are not limited to geology or astronaut antics. NASA has also glimpsed bizarre forms that push our ideas of life itself. Consider the time tardigrades, also called water bears, might have landed on the Moon after an Israeli spacecraft crashed. These microscopic creatures can survive extreme radiation, vacuum, and temperature swings. Though they need water to be active, they can enter a tun state and endure harsh conditions for long periods. If some crashed onto lunar soil, they might still be there, dormant but intact. This prompts ethical questions about planetary protection. Could we accidentally seed other worlds with Earth-based organisms? NASA tries to sterilize probes, but perfect decontamination is tough. Some fear we might compromise future searches for alien life by bringing stowaway microbes. Others argue that Earth's life spreading outward is part of cosmic evolution. Tardigrades aside, NASA also records odd phenomena like potential microbes near the space station. Officially, those space bugs are more likely dust or debris, but interest in living things that thrive in orbit persists. Long-term experiments with mice, flies, and plants show how biology changes in low gravity. Some plants grow oddly shaped roots, insect life cycles can shift. Each discovery deepens our understanding of evolution beyond Earth. Another cosmic puzzle is the possibility of life on Mars or the icy moons of Jupiter and Saturn. While NASA hunts for chemical traces, no conclusive evidence has emerged. Yet the curiosity lingers. If life endures in extreme pockets of Earth, from volcanic vents to polar ice, then perhaps somewhere else in the solar system holds a stable habitat. The tardigrade example shows how we underestimate life's resilience. Maybe NASA's next big reveal will be an organism that rose to the challenge of space. Even small objects like meteorites can carry amino acids. Some propose panspermia, meaning life might have traveled between planets long ago. Though unproven, it underscores how data from NASA's cameras can spark cosmic debates. Perhaps the day we spot a true alien microbe will come from an unplanned cameo in some roving lens. Could something beyond Earth already be watching us? The same way we track them with every new mission? Each time NASA captures the unexpected, we edge closer to answering if we are truly alone. Missions, views, and moon mysteries. NASA's cameras not only capture new life or raw cosmic structures, but also thrilling launches, landings, and strange lunar moments. In one time lapse, an astronaut snapped a cargo ship flying toward the International Space Station, creating a radiance trail across Earth's night side. The spinning planet below, dotted with city lights, clashed with the brilliance of the craft above. These visuals remind us that humans move back and forth to space almost routinely now. Another mystery arrived in the form of moon music. Apollo 10 astronauts reported eerie whistling sounds when orbiting the far side of the moon. Out of contact with Earth, they heard an odd noise lasting nearly an hour. Later analysis traced it to radio interference between lunar modules, but some still prefer more exotic explanations. The recordings only fueled speculation about hidden secrets on the lunar far side. The sun also offered bizarre views. Sometimes NASA images show glowing active regions forming a face-like shape. Nicknamed the Jack-o'-lantern sun, it may look spooky, but it is simply certain areas shining brighter due to intense magnetic activity. The swirling patterns highlight how dynamic solar plasma can be. While it seems playful, it underscores real processes shaping the corona. Even rock boosters returning to Earth produce mesmerizing footage. As the first stages glow red-hot upon re-entry, cameras catch them tumbling through the atmosphere, leaving streaks across the sky. For onlookers, it can appear like a meteor shower or a secret phenomenon. Yet NASA clarifies these events, releasing videos that capture every second of the hardware's fiery fall. As more agencies launch cargo and crew, such scenes will multiply. Soon, private missions and international programs may share even more vantage points. Every clip offers fresh wonder, fueling speculation about what else might drift into view. The cosmos never stops surprising us, and NASA coverage invites everyone along for the ride. So when you see rocket plumes lighting up the horizon, or hear about strange lunar tunes, remember each event holds a real explanation. Yet the sense of awe remains because so few have witnessed these sights firsthand. NASA's cameras shrink that distance, revealing the extraordinary behind our routine launches and orbits. Will the next mission reveal even stranger songs or sights? Beyond the everyday, growing food and hair in space. Beyond giant leaps lie small steps that keep astronauts alive and well. NASA often releases clips of daily tasks in microgravity, revealing how humans adapt to life without normal up or down. One example is the Space Salad Project. Astronauts grew radishes and lettuce on the International Space Station, showing it is possible to cultivate fresh food in orbit. Seeds were placed in small pods and then watered with care. Harvest Day arrived with excitement, as these plants are a taste of Earth in an isolated environment. Future missions to the Moon or Mars might rely on similar setups to provide fresh produce. Another routine chore is washing hair in zero gravity. One astronaut posted a video showing how she used small pouches of water and no rinse shampoo while her hair floated around her head. Without gravity, water forms blobs, so she carefully dabbed and massaged it in, then toweled off the excess. That moisture eventually entered the station's air, where filters reclaimed it for reuse. Such videos show how simple acts must be rethought in orbit. NASA's approach to daily life in space extends to cooking, sleeping, and exercise. Special ovens can heat food pouches while sleeping bags strap astronauts so they do not drift at night. Treadmills come with harnesses for running in place. Each detail ensures health and sanity over months away from Earth. NASA encourages crews to share these tasks on video, giving the public a direct look at daily realities that remain fascinating. Insights gained from these recorded tests could shape our push to settle the Moon or even Mars. If humans plan to stay long-term, they need stable food sources, effective hygiene, and ways to manage boredom. NASA's media releases show how we are inching closer to that goal day by day. Through each new clip of floating veggies or shampoo globs, viewers learn that survival in space is about inventive thinking and constant adaptation. Will these small steps lead us to permanent off-world home? The seeds of that future may already be sprouting in orbit. Seeing astronauts manage basic tasks reminds us that space exploration goes beyond rockets and rovers. It touches every part of daily life among the stars. Someday, these routines might be second nature for lunar or Martian settlers, proving that NASA's images of simple tasks paved the way for cosmic normalcy. NASA continues to reveal sights once hidden from public eyes, from giant solar flares to quiet water bears on the Moon. Each new video or image expands our sense of what's possible in space. Maybe the next discovery will challenge our knowledge even more. We hope you'll share your thoughts below. And please like, subscribe, and ring that bell for updates. Our universe remains vast and full of surprises. Thanks for watching, and stay ready for NASA's next mind-blowing capture.
That's the power of one of these asteroids. 10,000 Hiroshima bombs is the power packed by this piece of real estate.
Massive, fast-moving visitor to our solar system may have been a probe sent by an advanced alien civilization.
NASA has just identified a mysterious new object entering our solar system, feeling concerns about what it might be and where it comes from. Spotted by observatories around the world, the strange visitor has left astronomers in a race to understand its nature. Is it merely an odd cosmic wanderer, or does it pose a genuine threat? Stay with us as we break down NASA's findings and examine why this unknown arrival has everyone on edge.
First time ever, an object from interstellar space has been observed to visit our solar system.
The strange encounter. First detection. Telescopes around the globe began reporting odd readings in October when an unusual body was observed moving on a course beyond typical comets or asteroids. The object, located at the outskirts of our solar system, seemed to be coming from interstellar space. NASA's early data suggested it was approaching faster than predicted, prompting scientists to classify it as a potential cosmic anomaly. Word spread quickly, spurring urgent observations from agencies worldwide. Because it defied routine orbital patterns, astronomers worried about whether it might pose a threat. Standard modeling tries to match new objects with the known categories like comets, asteroids, or dwarf planets, but this one's behavior was baffling. It displayed no tilt typical of comets, nor the stable path of standard asteroids. Its brightness also varied strangely, suggesting an irregular shape or reflective patches. NASA soon ramped up data collection. tapping the Deep Space Network and partner observatories to gather critical information. Astrometry measurements aim to determine how sunlight and gravitational pulls might be influencing it. Astronomers also monitored for signs of outgassing, which might explain odd accelerations, yet nothing conclusive emerged, fueling speculation that this might be an interstellar traveler unlike any we've documented. Word of a strange object entering our region caused both excitement and anxiety. Over the years, sightings of unusual objects have often turned out to be harmless lumps of rock or ice, but the behavior of this newcomer made even seasoned astronomers uneasy. Meanwhile, NASA confirmed it was on a hyperbolic path, meaning it would only swing by once before slingshotting away unless an unexpected force altered its course. The object's sheer speed hinted at origins beyond the outer Oort cloud, possibly from another star. Pan-STARRS and other advanced telescopes provided additional glimpses, revealing flickers that might suggest rapid rotation. In short, everything about this cosmic visitor defied easy classification. With the NASA publicly announcing the detection, online chatter exploded over what this might mean. Could it be a chunk of a rogue planet ejected from a distant system, or even some sign of alien technology? The next step was clear: gather every bit of data possible while it remained in range. NASA started coordinating a worldwide watch, inviting ESA and JAXA and private observatories to pool resources. As one NASA official put it, "We don't want to miss another Oumuamua event without thorough study," and so began the frantic quests to decode this uncanny arrival from the depths of space, not knowing if we'd find comfort in routine answers or face a more unsettling truth about cosmic wanderers. Could this uninvited traveler be a mere wanderer, or is it the harbinger of something far more dramatic? NASA steps in, analyzing the object's nature. NASA quickly mobilized its Planetary Defense Coordination Office, PDCO, a branch dedicated to detecting and mitigating near-Earth object threats. The PDCO typically monitors asteroids and comets that might come too close for comfort, but this new intruder posed extra puzzles. For example, initial data showed it was highly elongated, turning slowly in a manner unlike typical space rocks. Some observers wondered if it was tumbling end over end or spinning around multiple axes. To learn more, NASA scientists used infrared sensors aboard orbiting observatories, such as NEOWISE, aiming to detect temperature patterns that could reveal composition. Was the surface icy or metallic? Could it hold pockets of volatile chemicals that might trigger unexpected jets? Meanwhile, radar facilities beamed signals to measure reflection times, mapping any lumps or protrusions. The biggest question was whether it fit known patterns or broke them. NASA's Jet Propulsion Laboratory took charge of evaluating the orbit. Early computations indicated a hyperbolic path with an eccentricity well above 1, meaning it was a one-way trip from outside the solar system. This classification mirrored Oumuamua and the comet 2I Borisov, the first confirmed interstellar visitors. Yet NASA found baffling discrepancies, minor speed fluctuations that standard gravitational influences couldn't explain. Some speculated outgassing might cause slight boosts, but repeated checks showed no visible coma. The object's reflectivity also varied more sharply than typical asteroids. NASA considered every possibility, from exotic ice to partial fragmentation. Data was inconclusive, fueling public chatter about alien craft or advanced technology. Although NASA officials emphasized that natural explanations usually win out, they admitted the current data left room for debate. While the PDCO assured the public there was no imminent impact risk, they acknowledged the unusual features merited deeper scrutiny. NASA's next step was to coordinate short observation windows with advanced telescopes like the Hubble and ground-based arrays to refine shape, spin, and reflectance properties. But time was short. The object would soon pass perihelion and exit quickly. Meanwhile, international labs prepared to examine spectral lines for chemical fingerprints. NASA even discussed sending a small probe, though no official mission was announced. Debates raged online. Was this another cosmic oddball, or the scary sign yet of unknown dangers? Scientists maintained calm, but stressed the importance of detailed observation. The object's unpredictable quirks pushed NASA into uncharted territory. One lead researcher stated, "We must keep collecting data until it leaves our backyard, so we can decipher what in the universe created this visitor." If NASA's best tools can't unravel the mystery yet, what deeper secrets lurk in the cosmic shadows? The object's bizarre characteristics. As NASA collected more data, puzzling characteristics continued to emerge. One key oddity was the object's trajectory, which didn't strictly match gravitational predictions. Small deviations suggested an unknown force or thrust, reminiscent of how Oumuamua displayed slight accelerations that defied standard cometary explanation. Scientists scrutinized every possible cause, from sublimation of hidden ices to magnetic effects never before seen at this scale. Its shape also raised eyebrows. Early modeling implied an elongated form, maybe 10 times as long as it was wide. Others argued it might be disc-like, depending on how it reflected sunlight. Either possibility defies conventional norms for asteroids or comets. Some even proposed that multiple fragments could be loosely bound, creating illusions of bizarre shapes and twisting spins. NASA's optical data from multiple angles lends partial support for an odd geometry. A second unexpected trait involved brightness fluctuations. Over short intervals, the object's brightness changed dramatically, suggesting an uneven surface or rapidly shifting orientation. If it spun quickly, that spin rate might have slowed or sped up, hinting at internal structure or outbursts affecting angular momentum. Yet no standard outburst patterns were detected in the images. NASA recognized that such strange flickers typically appear in near-Earth asteroids only if they're shattered or artificially shaped. Observations in different wavelengths revealed further secrets. Ultraviolet scans from certain telescopes found no sign of typical cometary dust, while radio checks for water vapor or organic compounds came up empty. This dryness contradicted the possibility that it was a typical ice-laden traveler from far beyond Neptune. Meanwhile, X-ray monitoring was inconclusive, leaving open the question of whether high-energy cosmic processes might be feeling its oddities. Astronomers also kept watch for plasma interactions as the object approached the Sun's heliosphere. Occasionally, the solar wind can cause neutral atoms to stream from a foreign body, but once again, data showed no clear signs of such phenomena. The entire situation felt reminiscent of Oumuamua's perplexing behavior. No coma, no tail, yet hints of forceful motion. All this led some to question whether we might be dealing with advanced technology. The idea stroked controversy, with mainstream scientists emphasizing the need for extraordinary proof. But curiosity lingered. Even NASA's top brass admitted they wouldn't dismiss exotic explanations outright. They recalled how each new interstellar object rewrote the textbook, urging vigilance in studying anything so alien to our solar system. Threat assessment. Is Earth at risk? Public anxiety quickly shifted to whether Earth was in harm's way. NASA's Planetary Defense Coordination Office announced no imminent collision risk, but swirling rumors online suggested doomsday scenarios. Officials clarified that while the object's path might bring it within the solar system's inner regions, all simulations showed a safe miss. The margin, however, was narrower than typical for distant comets. In case of a surprise approach, scientists pointed out the object's unknown mass and size. If it were small, it might break up in the sun's intense heat or disintegrate when encountering a planet's gravity. But if it were unexpectedly large and dense, a direct collision with Earth, though unlikely, could unleash catastrophic force. Experts reference past events, Chelyabinsk's meteor in 2013 or the Tunguska impact in 1908. Those were relatively small cosmic projectiles, yet caused significant damage. Should an interstellar visitor many times bigger strike Earth, the consequences would be vastly more severe. Even a grazing pass might disrupt satellites or produce meteor storms. NASA reaffirmed no evidence supported these worst-case outcomes, but recognized the swirling what-ifs. Astronomers also assessed the chance it might break apart near perihelion. Some comets disintegrate when too close to the Sun, producing showers of debris. If that happened, Earth's path might cross a trail of fragments, raising concerns about increased meteor activity. While aesthetically pleasing in small doses, a thick debris field could pose a space hazard. JPL assured the public that predictions didn't strongly point to such fragmentation. Despite official reassurances, fear lingered in certain corners of social media. Memes about an Armageddon object circulated, while conspiracy theories claimed NASA withheld vital data. In response, NASA organized a public Q&A, emphasizing that neither its speed nor path indicated a direct threat. They also explained the rigorous processes used to analyze orbits, detect anomalies, and flag potential risks. Still, the label terrifying gained traction, partly due to the object's bizarre traits. Psychologically, it felt ominous that something so foreign could slip into our solar system with so many unanswered questions. For many, it became a symbol of cosmic vulnerability. If we can't fully predict or classify such visitors, how prepared are we for genuine cosmic perils? Interstellar origins and possible alien links. The possibility that this visitor traveled from beyond our stellar neighborhood ignited speculation about alien connections. Scientists recalled how the first identified interstellar objects, Oumuamua in 2017 and 2I Borisov in 2019, challenged our assumptions about cosmic debris. Oumuamua's odd shape and unexplained acceleration triggered debates over whether it might be an alien probe. Now, with a similarly perplexing arrival, the question arose in you: could it be something not just from another star, but from another civilization? Mainstream astronomers remained cautious. They argued that nature often produces surprising objects, yet they acknowledged similarities. Both Oumuamua and this newcomer lacked typical cometary traits and displayed subtle acceleration anomalies. A few high-profile scientists known for their openness to advanced technology theories suggested scanning for technosignatures, radio signals, purposeful maneuvers, or unnatural electromagnetic patterns. NASA responded by coordinating with the SETI Institute to watch for unusual transmissions. If an advanced species aimed to investigate star systems, they might design probes to appear comet-like, hiding in plain sight. So far, no transmissions have been detected. Critics stress that no direct evidence pointed to an artificial origin, maintaining that extraordinary claims require extraordinary proof. They urged patience as data poured in from observatories. Another factor fueling alien talk was the object's possible reflective patches. Could those be metallic surfaces? Some wondered if it might be a segment of an alien spacecraft battered by eons in interstellar space. If so, it could be a piece of cosmic junk left behind by a long-dead civilization. Or it might be something purposeful, analyzing solar systems while passing quietly. Although unsubstantiated, the concept captured imaginations worldwide. The scientific community, however, reframed the debate. Even if we discover it's purely natural, it might still reveal cosmic phenomena never before documented, said one astronomer. That alone excites researchers since each new interstellar traveler expands our perspective on how planetary systems form and evolve across the galaxy. Another angle considered the object's potential to carry clues about star formation zones. If it originated from a region rich in certain minerals or ices, sampling its composition could highlight how protoplanetary disks function around distant suns. NASA scientists planned spectroscopic analysis, hoping to match any chemical fingerprints with the known stellar nurseries. That in itself would be a scientific windfall, providing a direct sample of an alien star's outskirts. The hunt for clues, international efforts, and rivalries. The global astronomy community rallied around this enigma, uniting researchers who otherwise compete. Collaboration sprang up between NASA, ESA, and JAXA, and private telescope arrays, sharing real-time results. Despite occasional friction, a cooperative spirit grew, fueled by curiosity and the desire to catch every detail before the intruder escaped. The synergy underscored how cosmic mysteries can transcend international rivalries, at least for a moment. Some agencies are worried about overshadowing ongoing missions. Europe's JUICE probe, NASA's missions around Jupiter, and China's lunar ambitions all demand public attention. Yet the spectacle of a never-before-seen object overshadowed smaller updates. Journalists lined up for interviews with experts, seeking fresh tidbits on trajectory or chemical traces. Funding bodies took note, as cosmic unknowns often spur budget approvals for new telescopes or advanced detection systems. Behind the scenes, though quiet competition simmered, which agency would be the first to produce a definitive study? Who might discover a new phenomenon or claim a noble-worthy insight? Despite open collaboration, the race to publish soared. Proposed intercept missions, like sending a high-speed probe for a near-pass, generated debate. SpaceX even hinted at interest, though the practicalities looked daunting. The object's fleeting presence meant time was short. Simultaneously, some governments grew cautious about revealing everything. Security-minded officials speculated about worst-case scenarios. If the object turned out to be artificial with advanced capabilities, what if it transmitted signals or triggered unknown effects? That paranoia led to some data classification in certain circles, though NASA maintained a fairly open stance. As part of the synergy, top-level scientists convened virtual conferences. They identified observation gaps, for instance, limited ultraviolet coverage or insufficient coverage in the southern hemisphere. Additional observational campaigns were organized promptly. The frenzy underscored an essential truth: no single telescope, agency, or country had all the pieces. Collaboration was vital to piece together the puzzle. Meanwhile, the object approached perihelion, the moment of truth for potential outgassing or fragmentation. Astronomers braced for a spike in activity or a final twist in behavior. A hush settled over the global watch, reminiscent of earlier cosmic events that had united watchers in anticipation. Everyone wanted to see if a distinct shift would confirm or debunk leading hypotheses. In this high-stakes cosmic chase, Will unity or rivalry define humanity's quest for answers? Future implications redefining our place in the cosmos. As the object hurtled closer to the sun, speculation on its broader significance intensified. If its anomalies pointed to unknown cosmic mechanisms, future research could reshape fundamental astronomy. Alternatively, if conclusive evidence revealed an artificial origin, we might be forced to accept we are not alone. NASA recognized that either outcome carried profound implications. Scientists debated possible next steps. Some suggested using large-scale sky surveys to ensure no other stealthy visitors slip past. Others called for urgent development of an interstellar interceptor, a nimble probe capable of rapid launch upon detecting any such anomalies. The idea, while bold, gained traction as a demonstration that humanity can respond swiftly to cosmic surprises. Philosophically, the events triggered reflection on our vulnerability. If random interstellar objects can show up with puzzling behaviors, what else might roam the galactic void? The object's approach reminded many that we exist in a swirling cosmic sea, open to influences far beyond our immediate neighborhood. It reignited calls to become a multi-planet species, ensuring survival against unpredictable cosmic events. From a scientific standpoint, everything hinged on analyzing the final data before the object curved away. Spectroscopic details, heat signatures, and rotational speeds might confirm or refute exotic explanations. NASA labs were used to process reams of sensor inputs. If the object's composition mirrored that of known asteroids, it might just be a weird, elongated chunk of rock. If not, the story could take an unforeseen turn. Culture, too, felt the ripple. Social media brimmed with memes about ominous space harbingers. Public interest soared, fueling fresh calls for expanded space funding. Even Hollywood got inspired, brainstorming film plots about cosmic visitors revealing startling truths. While NASA stuck to measured language, the tension in the air was palpable, like an unfolding cosmic mystery, urging watchers to question our place in a vast universe. In the final stretch, the object's departure spelled either closure or a deeper puzzle. Should it flash a bizarre final signal or break apart near the sun? The spectacle would be unforgettable. Should it just sail away quietly? We might remain haunted by lingering doubts. Either way, NASA's detection changed our cosmic perspective. The solar system feels less isolated, more like a crossroads for universal wanderers. NASA's detection of a terrifying object entering our solar system could be a turning point in space research. Whether it's a rare natural wanderer or something far stranger, our cosmic neighborhood may never feel the same. As scientists scramble to learn more, the mystery deepens, driving new ideas and sparking public intrigue. Will this discovery reshape our vision for planetary defense, or even reveal alien influence? Let us know your thoughts in the comments. Like, subscribe, and stay tuned for more cosmic updates. The next frontier awaits.
Dr. Kaku, I am very excited to talk about this. The discovery of an Earth-like planet a mere 4.2 million light years away.
After decades of research, construction, and a Christmas Day launch, we are getting more full-color images from the James Webb Space Telescope.
The James Webb Space Telescope may have detected its first alien signal from Proxima b, our nearest exoplanet's neighbor at just over 4 light years away. Could we finally have proof that we share the universe with another civilization? Today, we explore what makes this discovery so important and whether it holds the key to confirming life beyond Earth. Buckle up, this could be a key moment in our quest to understand the cosmos around us.
It will be years before that project becomes a reality. If it goes as planned, the journey to Proxima b will take about 20.
The astounding signal from Proxima b. News of a strange possible artificial transmission from Proxima b has startled scientists worldwide. This exoplanet circles a red dwarf star named Proxima Centauri, located only about 4 light years from us, practically next door in galactic terms. The latest data suggests the signal shows patterns that go beyond random noise, spurring talk of a genuine technological source. Past false positives taught us to be cautious, yet certain traits of this signal raise everyone's hopes. Proxima b has long intrigued astronomers because it lies in a zone where liquid water might exist, even though intense stellar flares might threaten any atmosphere. The possibility of detecting a structured, repeating signal from such a place is thrilling. If it truly originates from an alien intelligence, it could mark the first time humanity has captured evidence of life beyond Earth. Researchers have noted that the frequencies do not match natural sources like pulsars or cosmic gas clouds. In addition, the signal seems localized, as if it comes from a single point rather than a broad region. Specialists are working to confirm that it is not radio interference caused by earthly devices. Multiple observatories, including those in different parts of the world, are collaborating to verify its authenticity and try to catch it again. Still, an enormous question remains. If the signal is real, why is it aimed our way? Some theorize it might be an intentional beacon. Others propose we simply stumbled on a communication channel used by an advanced civilization that did not even realize we could listen. No matter the reason, the notion that a neighbor so close by could be sending coded transmissions is staggering. Previous claims of alien signals often dissolved under deeper analysis. This event, however, features unusual features that have scientists more hopeful. It may show slight modulations resembling encoded data, which nature rarely produces in a neat pattern. While it is too early to declare victory, many feel we have never come this close to picking up a genuine sign of non-human intelligence. Could this spark the biggest revelation in history, or just another false alarm in our cosmic puzzle? Proxima B's habitable zone and challenges. Proxima b sits in what many call the habitable zone, around Proxima Centauri, meaning its orbit allows for temperatures that might keep water liquid. Yet surviving near a red dwarf is not simple. These stars can flare violently, bombarding a planet with harmful radiation. If Proxima b lacks a strong magnetic field or dense atmosphere, any life on its surface might face serious obstacles. Still, hope endures. Perhaps the planet is tidally locked, with one side always facing the star. In that scenario, life could hide in the twilight band between scorching daylight and freezing darkness. Or complex life might evolve underground or beneath thick oceans, safe from stellar bursts. We simply do not know. Proxima b's mass is close to Earth's, implying gravity there would be similar to ours. That alone stirs excitement about potential Earth-like environments. Could it feature oceans, continents, and a stable climate over geological timescales? That possibly boosts its ranking as one of the most enticing exoplanets in our immediate vicinity. At the same time, the star's smaller size means Proxima b orbits extremely close, completing a full year in just over 11 days. This closeness increases the odds of strong radiation. Even so, red dwarfs live far longer than stars like our sun, giving life more time to find ways to endure. Some theories suggest alien biology might adapt to powerful UV flares, using special pigments or cellular shields. Scientists also debate whether Proxima b can hold onto a thick atmosphere under such conditions. If not, the planet could be barren despite lying at a comfortable distance from its star. Future data, especially atmospheric readings from advanced telescopes, may clarify these lingering thoughts. For now, though, it remains near the top of our list of promising worlds. The mere chance that it might host a thriving biosphere has fueled missions and proposed probes, including high-speed Starshot concepts. If the rumored alien signal is genuine, the planet's status shifts from theoretical interest to urgent priority. Suddenly, the idea of life beyond Earth could move from speculation to near certainty, only a short cosmic hop away. Even if no living things inhabit its surface, Proxima b stands as a prime stage for exploring star-planet interactions under extreme conditions. Understanding how orbits, flares, and atmospheres converge might teach us about life's adaptability throughout the universe. Is it a lethal wasteland or a hidden Eden? The race to confirm the truth pushes us onward. James Webb Telescope's game-changing abilities. When the James Webb Space Telescope took flight, its mission was to see the cosmos as never before. Built to excel in infrared detection, it pierces through dust clouds that block other observatories. While Hubble gave us iconic images in visible light, Webb goes deeper, capturing signals from the earliest galaxies and faraway exoplanets. That advanced reach is how it stumbled on the curious blip coming from Proxima b. Webb's instruments analyzed starlight passing through exoplanet atmospheres, revealing molecules like water, methane, and carbon dioxide. If something stands out like artificial chemicals or structured signals, it could raise strong hints of technology. This approach also helps scientists measure surface temperatures and detect potential markers of biological activity. Through spectroscopy, they can spot the fingerprints of life-friendly chemistry, or in some theories, evidence of industrial processes. One advantage of Webb is its massive sun shield and remote orbit, keeping it cold enough for sensitive infrared readings. That stillness reduces background noise. Meanwhile, the observatory's precision alignment system ensures stable targeting. With these features combined, Webb can pick up faint signals that earlier telescopes missed or dismissed as static. In the process, it transforms how we examine exoplanets near and far. The possibility that Webb might detect actual technosignatures was discussed when the project began, but no one expected results this soon. If the Proxima b signal passes all checks, it will mark a milestone for exceeding routine science goals. Nobody built Webb solely to find alien civilization, yet its capabilities make it a potent tool in that hunt. Of course, many signals once labeled interesting turn out to be natural phenomena, yet scientists say this new detection has spectral details that do not match typical cosmic radiation. The news remains preliminary, but teams are quietly thrilled at the chance that Webb may have captured a direct call or a straight broadcast from intelligent life. If so, that would be a crowning achievement for a telescope already hailed as a marvel. This development also spotlights how major leaps in technology can reveal surprises. Just as radio astronomy opened doors to pulsars and cosmic background radiation, advanced infrared instruments might open the door to cosmic neighbors. If verified, it could spur more investments and spark new telescopes or even interstellar missions aimed at Proxima b. That dream is no longer confined to science fiction. Thanks to Webb's sensitive eyes, it may be within our grasp. Could this single telescope be forging the greatest link yet between Earth and an alien world? The nature of alien signals, artificial or natural? Whenever a strange signal arises, the first question is whether nature alone could have produced it. Pulsars, quasars, and supernova remnants all generate complex waveforms. Gas clouds emit random bursts, stellar flares can appear on detection graphs. Still, a truly organized pattern, especially narrow in bandwidth, often points to artificial origins. Natural processes rarely confine themselves to tight frequency ranges unless they involve special resonance conditions. Scientists search for repetition, modulation, or unusual frequency drift that suggests a purposeful sender. They also rule out local interference from satellites or ground-based radar. If a signal passes these tests, the excitement soars. Yet history has cautionary tales. The famous "wow" signal from 1977 seemed promising but never repeated. Other signals once labeled alien turned out to be from microwave ovens or imaging software quirks. For the Proxima b event, researchers claim the waveform has a regular shift that might correspond to a rotating planet or orbit-based broadcast. Such a detail could be big, but thorough checks must confirm it is not a glitch. Patterns that look artificial at first can lose that mystique under closer inspection. The gap between a hopeful hunch and a proven detection is huge. If the signal stands up to scrutiny, a second question emerges. Is it deliberate or accidental? Civilizations might beam out messages to find others or use strong planet-wide transmissions for their own needs, which we intercept by chance. A random alignment in space-time might let us eavesdrop. The potential ramifications are vast. Contact protocols, how to respond, whether we interpret a meaningful message or just a fragment of data. A final consideration, advanced civilizations might employ frequencies or methods beyond our current grasp. If we catch something, it could be a minor artifact of a technology far beyond ours. That scenario brings wonder and humility. We might realize we're detecting only a small piece of a grand puzzle. If we confirm an otherworldly handshake, how will it reshape our science, culture, and sense of belonging in the cosmic arena? Proxima Centauri system, past findings and ongoing mysteries. Proxima Centauri has attracted attention since astronomers confirmed Proxima b in 2016. Using the radial velocity method, they detected slight wobbles in the star's motion, indicating a roughly Earth-mass planet orbiting at close range. That alone was a headline event, suggesting the nearest star to us might hold a habitable zone planet. Soon, rumors circulated about additional planets or belts of dust. Some data points to a possible Proxima c, though it remains uncertain. Red dwarfs like Proxima Centauri complicate the habitability question. They often produce intense flares and radiation storms that can strip away planetary atmospheres. Observers found evidence of repeated bursts from Proxima Centauri over short periods. If Proxima b lacks protective shielding, life as we know it could be unlikely. Yet others propose life could adapt underground, beneath water, or within thick clouds. Organisms on Earth have survived in extreme environments, so perhaps evolution on an alien world managed solutions we cannot yet imagine. Over the years, telescopes from around the globe kept watch on Proxima Centauri, tracking changes in brightness and spectral shifts. Each glitch or spike led to speculation about unseen phenomena. The star occasionally dims or brightens unpredictably, fueling talk of unknown processes. Some suggest star spots or cyclical magnetism. Others suspect more undiscovered planets. Coupled with its closeness, these mysteries keep Proxima at the forefront of exoplanet research. Now, with James Webb's advanced vision, we can probe deeper. Scientists can measure atmospheric signatures more accurately, searching for molecules like ozone, methane, or even artificial gases. If something stands out, it can confirm that Proxima b remains stable enough to sustain interesting chemistry. The new signal, if linked to advanced beings, would overshadow all prior anomalies, showing that speculation about intelligent life might hold merit. Yet caution stands. The system's flaring nature might also mask or distort signals. The random blasts of charged particles can create false readings or overshadow faint transmissions. Researchers must disentangle these layers of noise. That is why cross-verification with different wavelengths and telescopes is key. A robust approach ensures we do not chase illusions caused by star behavior. Meanwhile, projects like Breakthrough Starshot imagine sending tiny probes to Proxima Centauri at a fraction of light speed to get direct snapshots. That plan remains theoretical, but gains new relevance if we have real hints of advanced life there. Even short of that, continued watch by JWST and ground-based arrays could reveal more. Every new piece of data adds to the puzzle of whether this star system hides a living planet on our cosmic doorstep. Implications of a confirmed extraterrestrial signal. If the Proxima b signal proves authentic, the repercussions would be staggering. Humanity has debated for centuries whether we are alone in the universe. A confirmed alien broadcast, especially from a planet so close, would answer that question overnight. We would face a sudden shift in worldview, no longer a solitary voice in cosmic darkness, but a part of a broader community of intelligent life. Governments and organizations worldwide would scramble to coordinate a response. Many nations have guidelines about first contact, but these are mostly theoretical. Questions would arise. Do we reply? If so, how? What if the senders have far more advanced knowledge? Scholars from every field, religion, philosophy, psychology, would weigh in on how to handle contact. Public excitement might surge, though fear could also appear, fueled by unknown intentions. Scientists would attempt to decode the signal's content. Was it a greeting, a demonstration of technology, or routine chatter? Interpreting an alien language could be a puzzle. Even if we recognize patterns, bridging the gap in biology, culture, and math might be a huge challenge. Some might propose sending our message back, risking the possibility of revealing Earth's location and vulnerabilities. Economically, space research funding might skyrocket. Private companies and public agencies could rush to design new telescopes or spacecraft to investigate Proxima b up close. The idea of building faster propulsion systems or advanced communication devices would intensify. We might see an explosion of science and engineering progress, led by the hope of bridging the gap between star systems. For everyday people, life on Earth might feel different. Our sense of uniqueness would vanish, replaced by the idea that we share the galaxy with other minds. Some could find comfort in that knowledge. Others might question their beliefs. The media frenzy, too, would be immense, saturating every news outlet with updates and speculation. Society could unite in wonder or fracture over fear of the unknown. Even if direct contact never advanced beyond a one-time detection, the events alone might fuel generations of inquiry. We would yearn to know if Proxima b's inhabitants live in cities, use advanced tools, or gaze at the sky searching for neighbors, just as we do. The chain reaction from such confirmation might rewrite our future, driving us to collaborate on the biggest challenge in history, communicating or visiting across interstellar space. Are we prepared for a reality that includes cosmic neighbors only for a few light years away? How this changes our drive for habitable planets. A successful alien signal from Proxima b would spark huge momentum for finding more life-friendly worlds. People have always dreamed of discovering a second Earth, but that dream would shift from curiosity to urgency. If advanced beings thrive next door, it suggests planets like ours may be common. That knowledge would inspire deeper hunts for other star systems that might hold life or resources. Projects like Breakthrough Starshots, which envisions tiny probes propelled by laser sails, could gain extra support. Why limit ourselves to imaging from far away if we can attempt direct exploration of Proxima's environment? the potential to confirm an alien presence in person or to map out their planet's details might rally global cooperation on an unprecedented scale. Rival nations might unite in pursuit of a shared cosmic goal. Moreover, this discovery would energize colonization plans for worlds that do not host life, especially if we conclude that inhabited planets should remain untouched. The ethics of stepping onto a living biosphere are complex. If we found Proxima b bustling with life, we might redirect human expansion toward unoccupied exoplanets. Alternatively, we might learn from that civilization if they welcome any exchange. The possibilities spark intense debate about contact protocols and ownership of space territories. Economics and technology would also evolve. Pioneering starship designs might explore everything from fusion rockets to advanced matter-antimatter concepts. Our sense of the timeline for traveling for light years could compress if the will and funding exist. Even if such voyages remain generations away, the impetus to push boundaries would be stronger than ever. Schools, universities, and private labs might produce breakthroughs in energy, artificial intelligence, and communications. Meanwhile, the broader population might shift how it sees Earth. If we are not alone, we might value our planet's unity over petty conflicts. Some dream that knowledge of neighbors foster peace, encouraging us to present a mature face to whoever might be listening. Whether that dream holds in practice is another question. Yet the spark of unity could flourish if humans realize we are part of a cosmic tapestry. A mysterious signal from Proxima b, caught by the James Webb Space Telescope, may bring us closer than ever to answering the oldest question: are we alone? If confirmed, it will reshape our future, from how we see ourselves to the missions we plan. For now, we watch, we wait, and we dream of forging new frontiers in our cosmic neighborhood. Thank you for joining us on this journey. Please like, subscribe, and share your thoughts below. The universe might feel the same again.
This is a potential game changer. NASA has hit pay dirt. You realize that ice is worth 5 times, pound for pound, 5 times the value of gold on the moon. The Chinese have announced that they're going to go to the moon. In fact, they will probably beat the United States.
Renowned physicist Michio Kaku has unveiled astonishing details about China's secret findings on the moon, from unexpected water sources to a groundbreaking new lunar mineral. These revelations might greatly reshape humanity's path to space. Even NASA is on alert as China plans to establish a station around the moon, possibly overtaking American missions. Today, we analyze Kaku's insights and discover how China's lunar successes could change our cosmic future entirely.
For the first time, China's space agency has launched a civilian astronaut into orbit.
China's lunar ambitions. China's National Space Administration, CNSA, has embarked on a bold campaign to explore the moon with unprecedented speed. Over the past decade, the Chang'e program has launched a series of robotic missions that have astonished observers worldwide. Each mission builds on the last, advancing from simple orbital flights to landings, rovers, and sample returns. Many experts point to Chang'e 5, which brought back lunar rocks for the first time in almost 50 years, as a pivotal triumph that signals China's leap in space capability. Even NASA officials have acknowledged that China might soon catch up or even surpass certain US lunar goals. While NASA focuses on its Artemis missions, aiming to place astronauts on the moon again, China's timeline appears equally ambitious. They have declared intentions to put humans on the lunar surface before this decade ends, and then establish a base to support research and potential resource extraction. They plan to harness lunar materials while forging a new path forward. Still, competition can spark innovation. The old Apollo missions produced breakthroughs in computing, material science, and rocketry. Today, we might see a similar boost if NASA and CNSA push each other to excel. However, there is also concern that secrecy around these new missions might limit global cooperation. Many astronomers hope that both agencies share data, enabling a deeper understanding of the moon's mysteries and fostering collaborative efforts. If China's sample analysis reveals new clues about lunar geology, scientists everywhere could benefit. Michio Kaku, known for simplifying advanced physics, has become a key voice in these developments. He knows that every time we think we understand the moon, a new finding overturns old assumptions. For instance, fresh evidence of water at unexpected locations or unexplained mineral deposits might force geologists to revise theories of how the moon formed. According to Kaku, if China keeps surprising everyone with new revelations, it could transform the field of lunar science in mere years. One aspect that NASA has recognized is the sheer speed of China's progress. The The Chang'e landers rely on advanced guidance systems tested first in Earth orbit. Rovers like U2 Rove, lunar terrain, and return data that shapes follow-up missions. Each step is methodical yet rapid, reflecting a broader strategy. Build expertise in robotics and resource mapping, then pave the way for a permanent station. Scientists around the globe are watching closely, eager to see whether China can sustain this pace and deliver the breakthroughs everyone hopes for. Could this Chinese push rewrite everything we thought we knew about Earth's nearest neighbor? Michio Kaku's take on China's moon discoveries. Michio Kaku, a physics professor recognized for explaining complex topics in simple ways, has watched China's lunar breakthroughs with keen interest. He believes these missions are not just about national pride, but also about rethinking the moon's role in humanity's future. According to Kaku, every new finding from Chang'e or related programs forces experts to question old models of lunar formation and evolution. He suggests that revelations of hidden water, rare minerals, and even unusual surface features could rewrite lunar science. One highlight for Kaku is the detection of water in places that once seemed impossible. China's probes have identified signs of water-bearing compounds in glass beds formed by meteor impacts, as well as near polar craters where the sun never shines. Kaku notes that if water truly exists in large amounts, it's a game changer. Future bases wouldn't have to rely solely on shipments from Earth. This means easier life support, local agriculture, and even fuel production if we split water into hydrogen and oxygen. That possibility could drastically lower the cost of sustained lunar presence. Kaku also points to helium-3, a rare isotope that some see as a cleaner path to nuclear fusion. While the idea of mining helium-3 from the moon has been around for years, actual proof that it exists in usable quantities has been scarce. China's sample analysis from Chang'e 5 indicated a potential for helium-3, though the real amount and accessibility remain in question. Kaku emphasizes that if any nation does harness helium-3, it could lead to an energy revolution on Earth, but only if we overcome massive engineering hurdles first. Beyond resources, Kaku is excited about the new lunar mineral discovered in Chang'e 5 samples, often called Chang'e. Scientists believe it may hold clues to the moon's volcanic history. For Kaku, each newly identified mineral or chemical signature is like a puzzle piece, helping geologists form a richer picture of how the moon evolved across billions of years. He warns, though, that the intense focus on resources might overshadow the pursuit of pure knowledge. Balance is key, he says. We should not treat the moon as just a giant fuel depot. Kaku's final point revolves around international cooperation. Despite headlines about a space race, he hopes major powers see the value in sharing data. The moon belongs to everyone in his view, and discoveries that clarify its geology or potential for sustaining life should be available to all. If we let competition drive secrecy, vital research might stall. Instead, Kaku envisions a global partnership that merges the strengths of many nations, leading to deeper lunar insights and perhaps settling a template for exploring other worlds. If Michio Kaku's predictions hold, are we on the verge of a lunar gold rush or something even more dramatic? Water on the moon. China's surprising evidence. One of the biggest surprises from China's recent lunar missions is the evidence of water in unexpected areas. Traditionally, scientists believe the moon was bone dry, aside from small icy patches in permanently shadowed craters. Yet Chang'e 5 found that glass beads scattered across the lunar surface might hold water. These beads likely formed when meteorites slammed into the moon, melting rock and then cooling in spherical droplets. Over time, hydrogen atoms from the solar wind could bond with oxygen in the beads, creating trace amounts of water. Even though each bead holds only a tiny bit of water, there might be countless beads spread across vast regions of the moon. In theory, if you collected enough beads and heated them, you could extract meaningful quantities of water. This discovery challenges older assumptions that any water on the moon must come from comets or remain locked at the poles. Instead, a slow but steady water cycle could exist, fueled by the sun itself. While it's not a rushing river or a giant ice lake, it still provides hope for future explorers seeking water sources. Chang'e missions have also mapped areas near the lunar poles, confirming the presence of ice in craters that never see sunlight. Many experts see this ice as more accessible than previously thought. If China's data is correct, some of these dark craters might hold layers of ice thick enough to supply a small outpost for months or even years. NASA is investigating the same regions through its Artemis program, planning to land near the South Pole. The difference is that China's sample return has offered physical evidence that scientists can analyze in labs back home. That said, skeptics caution that we still lack a complete picture of the water's distribution. The moon's surface is constantly bombarded by micrometeorites and solar radiation, which can shift or destroy these fragile deposits over time. Some scientists worry that the water might only be found in scattered pockets, making extraction difficult and expensive. Yet even partial success could be invaluable. Having local water means easier manufacturing of oxygen for breathing or rocket propellants for journeys deeper into space. Could these hidden lunar reservoirs be the key to humanity's permanent footprints on the moon? Helium-3 and the prospect of lunar energy. Among the most talked about lunar treasures is helium-3, a rare isotope that excites scientists dreaming of fusion power. Unlike the usual helium on Earth, helium-3 has a unique atomic structure that, in theory, could fuel a new type of fusion reactor with far less radioactive waste. Because the solar wind constantly bombards the moon with charged particles, including helium-3, some experts believe its surface may contain significant deposits. Chang'e 5 soil samples offered hints of helium-3 locked in fine dust. While the concentration is still unknown, the very presence of helium-3 validates decades of speculation. Some see this as a possible solution to Earth's energy crisis. If we could mine helium-3 and develop workable fusion reactors, the payoff might be almost endless clean electricity. Yet the obstacles are enormous. Extracting helium-3 would involve processing vast amounts of lunar soil for tiny yields, and building functional fusion reactors is far from certain. Physicist Michio Kaku is both hopeful and cautious. He calls helium-3 a holy grail, but warns it could be a mirage if the actual amounts are too small or buried too deep. Also, any large-scale mining on the moon brings environmental and ethical concerns. The moon's near-vacuum environment and extreme temperature swings complicate mining operations. Moreover, legal frameworks under existing treaties remain blurry on who owns lunar resources. If one nation sets up extraction facilities, it might trigger international debates on property rights and space law. In parallel, private space companies have also begun eyeing the moon's helium-3 potential. They pitch mining as a business venture that could yield huge profits down the line, yet no company has proven the economic viability of shipping helium-3 from the moon to Earth, let alone building and operating fusion plants that can handle it. Realistically, it might take decades or even a century to see any tangible benefits, assuming it's all feasible. If China taps into helium-3 first, could this reshape global power and energy forever? China's lunar missions have shed new light on the moon's rocky shell, revealing features that challenge old beliefs about its volcanic activity and surface age. Before the Chang'e missions, scientists assumed the moon had cooled billions of years ago, leaving it geologically dead. Yet Chang'e 4 and Chang'e 5 data suggest some regions might have stayed volcanically active more recently than expected. In particular, the smooth plains in certain lava-filled basins appear younger, hinting that volcanic flows continue longer than we once thought. Volcanic samples returned by Chang'e also introduced an unexpected twist. They show minerals that may be far younger than anything brought back by Apollo. This has forced a rethinking of lunar chronology. If the moon remained active for a billion years more than we believed, it could explain certain unusual surface markings. Scientists are now debating whether the moon's interior cooled unevenly or if external factors like asteroid impacts trigger bursts of lava. Either way, the story of how the moon evolved is becoming more complicated and interesting. Another odd finding involves strange pits and hollows that appear to form when volatile elements escape from beneath the surface. Messenger missions around Mercury have found comparable hollows, but seeing them on the moon challenges the assumption that Mercury is alone in that phenomenon. Some geologists wonder if these hollows might connect to underground tunnels or pockets, possibly left over from ancient lava tubes. If so, such tubes could provide natural shielding for future human settlements, protecting them from radiation and temperature extremes. Comparing these fresh data with the polar-era rocks has generated exciting questions. NASA's older samples mostly came from equatorial areas. China's missions are exploring different latitudes and terrain types, possibly uncovering a broader range of lunar geology. The chemical differences in the new samples may reveal local anomalies or global trends missed by earlier missions. Overall, we see a patchwork of volcanic histories, mineral compositions, and hidden cavities that paint the moon as a dynamic place, at least in the past. Yet deciphering these complexities requires open sharing of data between countries. Chinese scientists have published some findings, but others remain limited. Western researchers hope for deeper collaboration. so they can match Chinese results against archived Apollo data. If that synergy takes hold, we might assemble a truly global understanding of the moon, bridging decades of separate research. Could these younger volcanic signs suggest the moon is far more dynamic, with surprises still lurking beneath its surface? Looking beyond short-term missions, China has sketched an ambitious plan for a lasting lunar presence. The idea of an International Lunar Research Station, ILRS, has caught worldwide attention. Although details remain sparse, China envisions sending robotic landers and rovers in the next few years to scout potential sites for a station, focusing on areas rich in water ice and valuable minerals. The station could host scientific experiments, test new technologies, and maybe even form a stepping stone to further adventures into deep space. One factor driving this push is the potential for in-situ resource utilization, or ISRU. This means relying on local materials, like lunar water for drinking or rocket fuel, to cut down on the enormous cost for hauling supplies from Earth. If the data from Chang'e missions holds up, the availability of water or oxygen-bearing compounds could revolutionize how we approach space travel. Instead of single-use missions, we could have self-sustaining outposts that produce their air and water. China's timeline often prompts comparisons to NASA's Artemis program. Artemis aims to land astronauts on the moon soon, with subsequent steps leading to a lunar gateway station in orbit. While NASA's approach is multinational, featuring collaborations with Europe, Canada, and Japan, China seems to be forging alliances with Russia and possibly other nations. The question is whether these parallel programs can coexist peacefully, or if they will lead to rival spheres of influence on the lunar surface. Some experts caution that a new space race might hamper global cooperation. Others see it as healthy competition that spurs faster progress. Either way, Michio Kaku suggests that once a permanent station is in place, the entire concept of space travel changes. Instead of launching everything from Earth's gravity well, we could stage missions from the moon, where low gravity means cheaper launches and more frequent flights to Mars or beyond. This might set in motion a chain reaction of engineering leaps that define a new era of space exploration. As China sets its sights on a lunar station, will America risk losing the next big leap in space? What if China's moon secrets truly transform everything we know about Earth's lone satellites? Michio Kaku highlights two possible paths. The optimistic view is that fresh discoveries, water reserves, new minerals, or simpler ways to build habitats could bring nations together in a shared quest for knowledge. If China demonstrates that living on the moon is feasible, then all countries might rally to develop advanced research stations and keep the lunar environments protected. On the other hand, Kaku warns that bigger lunar finds might ignite a fierce scramble for resources. If helium-3, for instance, proves to be a realistic energy source, we could witness intense competition over prime mining zones. Tensions could arise if multiple countries claim the same crater or set up extraction rigs within miles of one another. Existing space treaties are vague about resource ownership, which could spark legal disputes or geopolitical friction. In a worst-case scenario, the moon becomes a new frontier for rivalry rather than cooperation. Kaku also mentions the possibility of discovering signs of earlier cosmic events, like ancient meteor impacts that shaped Earth's environments or delivered key ingredients for life. If China's missions trace these events in greater detail, it might answer questions about how water arrived on Earth, or even how life began. That knowledge would be priceless for the entire human race. The hope is that politics won't overshadow science, preventing the free exchange of such groundbreaking findings. Ultimately, the moon's secrets extend beyond resources. Understanding its internal structure, geological processes, and possible hidden cavities might help us unravel the early solar system's history. The more we learn, the more we see that the moon is not just a lifeless rock, but a window into cosmic evolution. For centuries, it was a beacon of myth and romance. Now it appears to hold data that could shape our species' future among the stars. We face a choice: treat the moon as a zone of competition or as a shared stepping stone into outer space. In Kaku's vision, a strong global partnership might be the best route, merging advanced robotics, rocket tech, and scientific expertise from multiple nations. By pooling knowledge, we could avoid duplication and accelerate breakthroughs. The question is whether humanity can set aside national pride long enough to see the bigger picture. If China's leaps in lunar exploration motivate unity rather than conflict, then the moon could become the cradle of our next giant leap outward. forging a new chapter in civilization's cosmic journey. Michio Kaku's revelations about China's lunar achievements show how the moon may hold unimaginable potential. We're seeing evidence of hidden water, exotic minerals like helium-3, and hints of recent volcanic activity. Each breakthrough could fuel a new space age, but also raises questions about cooperation, resource rights, and the ethics of space mining. Will these discoveries unite the world or trigger intense competition? Let us know your thoughts in the comments. If you found this fascinating, like and subscribe for more. The moon's future might define our own.